session is going to cover what's new in NX CAD. So we're going to be talking mostly about what's new in CAD and NX 2306. I think there's one command that we'll also cover that came about in NX 2212. So for most of you that might be using earlier versions, hopefully this will be relevant to an update that you'll be looking to be doing here in the near future. And actually, coming up in about a month or so, we've got NX 2312 just right around the corner. So we'll have some more updates for you here in the near future. So let's get into our topics here for CAD. I just want to start off by introducing myself. My name is David Chu, and I'm with Swish Technologies. I'm based in St. Louis, Missouri. I'm currently the Customer Success Manager here at Swish. So my primary responsibility is just really to make sure that customers are successful using our Siemens software products that we provide. So I oversee those efforts. I've spent a lot of years in technical roles. I've been an NX and Team Center instructor. I've also helped to install software, worked in support for technical issues, helped to implement Team Center, both installation, configuration, and support of deployments. So if you think there's anything I can help you with, feel free to reach out to me. My email and phone number there are on the screen. And if you would like to reach out to me and connect on LinkedIn, you'll see my QR code there. Also, welcome the connection there as well. All right, so here's our agenda for this session. We still have a lot of customers that are using older releases, even back to before what we call the continuous release series of NX came out. So in terms of numbers, we're talking about NX 12 and earlier. So before we get into the different releases and the updates there, I want to just do a quick review of what we're talking about. There's been a couple different changes to the version numbering for NX. So if you're still working on, let's say, NX 12, and you're looking at these 4-digit numbers trying to figure out what's what, hopefully I can help you make some sense of that, and then work with you at some point to get you up to speed on the latest versions of NX. So we'll do a quick review of that, and then we'll get into the really kind of the core capabilities of NX CAD. So we'll talk about some enhancements in these different areas that you see here, with sketching, modeling, assemblies, and drafting. So in 45 minutes, we'll hit some highlights. Don't think I'm going to be able to cover every single enhancement. There's a lot of them, of course. So I'm going to end up with some links to where you can get more information. There's a variety of sources that you can tap into to get information on other enhancements or even more details on some of the things that you might see here. So let's go ahead and get into it. I'm going to go back to the beginning of last year. So after NX 12, Siemens went to a 4-digit version code, and at first the date codes weren't being used, but getting into middle of last year, as you'll see in the June 22 time frame, the version numbering switched over to something that's more like a date code. So we're talking about beginning of last year, the latest release was NX 2007. Which was not tied to a date. And then you get to NX 2206, so that's June 22. And then you've got December of 22, that's the 2212 release. So, if you haven't upgraded past NX 12 yet, you'll notice something a little bit different than what we had before, where the major releases are coming out every 6 months. So it's a lot faster upgrade process. And, it's called continuous release because you can just continually upgrade, even between releases. There's monthly updates that are available before you get to the next major upgrade. So coming about to the beginning of this year, let me go up to 2023. Again, in December, the 2212 release came out. The latest release that's available right now is the June version, which is 2306. That's the version I'm going to be running in my demos today. And we've gotten pretty close to when 2312 is going to be coming out. So we'll be looking forward to some new updates here right at the beginning of the next year. We'll be looking at NX 2306. Okay, so let's get into the sketch enhancements. There's several sketch enhancements that I'm going to be able to show here. You see them listed on this slide. One of the things that some of you might have to look forward to is switching over to a new sketch tool. So I think starting in might have been NX 1953, maybe even 1926. A new sketch tool was made available in NX, and the whole idea was to make the sketching process easier and more flexible. Um, what came with that was a different way of thinking about things. We didn't have constraints anymore. We've got relations, which you can relax and more easily change how sketches were defined. I'm going to have to try to be careful to use the right terms. We're not talking about constraining sketches. We're talking about defining sketches now. So the previous sketch was called a legacy sketch, and we've got the new sketches available. So there's been an enhancement to how you can mix and match the different sketches going forward into NX 2306. The other enhancements I'll show here in this section of the presentation deal with specific enhancements within the sketch tool. There's the feedback you get, the visual feedback that you get when you work with sketches that have conflicting definition, I'll say constraints, just because that might be more recognizable from past history of working with NX sketches. So when you go through and work with some of the settings like the show movable option, it'll highlight for you some of the conflicts that you might have. And there's been some other things that have been enhanced here for some of the geometry creation. So the rectangle from center command works a little bit differently now. I'm not going to spoil it yet. I'll get to that one here in a minute. And then for fillets, there's a couple different ways that tangencies are displayed using the found relations. So I'll try to show that. And then for editing purposes, the reattach sketch command has been made easier to use. You don't have to use it within the sketch edit mode. You can work with it outside of the sketch. So I will demonstrate that as well. So let's take a look at some details. So I mentioned before, you've got the new sketch that's available. It has a different toolbar, which you'll see in a minute if you haven't seen it yet. If you are using one of the later versions of NX, you're probably fairly familiar with it. But there might be some times where you're bringing forth into the newer version of NX parts that have sketches created in earlier versions that use the legacy sketcher. So up until NX 2306, you had the choice of continuing to work with the old sketch, the legacy sketch, or to upgrade your legacy sketch to the new sketch, and that uses the renew feature command. So this was done through an early access feature. I'm going to show how that's turned on and how that's set. And that's another one of the changes where you don't have to actually exit NX to make that choice. You can make that setting, change that setting right within your NX session without having to restart NX. So I'm going to go ahead and switch over. Let's take a look at what this looks like. So let me get up my NX session and open up an old training file of ours. Give me a chance to open up this model. So in this is a pretty simple part. You'll see on the screen here in just a moment. You'll see the sketch sitting there, and that sketch was extruded to create a solid model. This is one of our start parts for a training exercise. And as you can see here, it has a sketch that was used to define this. If I double click this sketch, and if you take a look at the toolbar, even those of you that are still using NX12, the ribbon bar up here and the icons might look familiar to you. This is the legacy sketch toolbar, and I can tell this because it's got dimensions as a set of commands up here. We've got constraints, so that's definitely a tip off there. When we talk about constraints, that's the legacy sketch. Down in my message line, that's here, my sketch is fully constrained. So in NX 2306, I can continue to work with the legacy sketch. You go into edit mode, you can go ahead and work with the same commands that you might be familiar with already. Now, if you want to work with the new sketches, if I were to go create a new sketch, let's go ahead and click the sketch icon on the toolbar. I'm just going to go ahead and select a different face on the model. Okay, so here, and now if you compare that previous toolbar to the new toolbar here, you'll see you've got the similar geometry commands up here on the icons. You don't have any dimensioning commands. You don't have any constraint commands. You see some references to relations. So this is the new sketch environment. And I'm not going to get into a full-blown sketch, but I will go in and just go ahead and create some geometry here real quick just to show that we have a sketch sitting here. And so let me go ahead and create a profile. And I know I've got a closed profile because my boundary has the shading within the lines there. So there's my new sketch. So one of the new things that has been added to NX 2306 is I can have multiple types of sketches in the same part within the same session of NX. I can go back to my original sketch, double click that. You see I've got the old, I'm going to call it classic, the classic toolbar. It's the legacy sketch. And if I get over here and let's go to the new sketch, there's the new sketch toolbar. So this behavior is controlled by something called an early access feature, and that's going to be down in your utilities. So up here, now, I think a lot of you are going to be familiar with your customer defaults. If you take a look at this drop-down menu that shows up here, next to customer defaults, you'll see early access feature. Let me show that to you here. If you go in here to the early access features, you'll see there's lots of them, and they do relate to different applications within NX. So we're looking for one for Sketch. Let me just start typing Sketch, and just like with Google, it's going to filter that list. Now we see the setting for which Sketch environment you want to work with. So here it is. So remember when I clicked the Sketch icon to create a new sketch, it did go ahead and get me into the new user interface. So out of the box, when you're in NX 2306, when you create a new sketch, the new solver is going to be available. Now, you can change that. You can right-click here and turn it off. And then if I can go find my OK button, which is way over here to the right. So let me go ahead and click OK. So I'm going to turn it off. Now, notice again, another change here is that you don't have to restart NX. If you see where my cursor is, you don't have to start NX to affect this change. So it's not like a customer default where you have to exit NX and come back in. So let me go ahead and click OK there. And if I go ahead and create another new sketch, let's put one over here on this side. I'm going to go ahead and select that face. Let's go ahead and if you see, I've got the, again, I'm going to call it the classic. I like classics. So I've got the classic toolbar. I just throw a sketch out here just to have something to look at. All right. So now, if you just kind of going back, this is not anything new what I'm going to show you right now, but just to kind of close the loop here, if you do prefer the new sketch and you want to go forward with the new sketch, let me go ahead and let's show how the renew command works. I need to go back and set my early access feature back so that you can see it here. This one's been changed. You see how it's highlighted in the blue. So I don't have to do a filter or anything like that, so I can easily find that. Let's change that back to on. Let's use the new sketch environment. And then I'm going to go ahead and it's actually easier for me to go through the menus. We're going to edit, feature, and we're going to renew feature. You can also, of course, type that in the command finder. So you see what I've got here. Yeah, so this is NX8. So this original sketch that I had here was from NX8. You can see the new sketch I created as a legacy sketch. It was even created in the current version, 2306, but it's still a kind of an out-of-date feature if you want to think of it that way. So I'm going to go ahead and let's just basically select this first sketch. Click OK. It updates that sketch. If I double-click on this, you'll see I've got the new toolbar, and the sketch behavior is going to be different, of course, based on how the relations are applied now and how the sketch is defined. So that's the way we talk about it going forward into the new sketch. How is the sketch defined? Is it fully defined? Is it partially defined? Are there movable curves in the sketch? Those are all new terms that we all want to get used to. Okay, so I'm just going to go ahead and update to the last here. There's my model. So I think that's a big deal. We've got a lot of mixed feelings from customers on which sketch environment that they prefer to use, and now you can work with both. Now, I will say though that once you renew a sketch and make a legacy sketch, update that to the new style sketch. You can That's a one-way street. You can't go backwards. So that's not necessarily new in 2306. That's the behavior of the new sketch ever since it was introduced. Once you upgrade a sketch, um, a legacy sketch to the new sketch, you can't convert it back. So if that's really important to you, just make sure you take a backup copy of your model in case you really need to go back and do something with it. Okay, so let's go back to some slides here. I'm going to hit a couple of enhancements, just kind of give you an overview before I get back into a demo. So the first one here I want to talk about is the show movable command. So these enhancements I'll be talking about are going to be relative to the new sketch environment. There's no enhancements to the legacy sketch. So you do have to be working in the new sketch solver to see these. So there's a command called show movable, and it highlights the geometry in your sketch that are movable, which means they're not fully defined. And you can also find curves that are movable by putting your cursor on a curve and seeing if you just click and drag, see if it moves. So this command has been enhanced to kind of like with over constraint sketches in the legacy sketch to show the conflicting relations and dimensions. Highlight those in red if you have that situation. So I'm going to go ahead and try to create one to show you what it looks like. And then there's the ability to create different kinds of relations. I'm going to try to explain this in case you haven't been working with the new sketches yet. So in the new sketch, instead of constraints, there are relations, which look a lot like constraints, but relations can be discovered by NX when you start to make some edits. Those are called found relations. Or they can be added to the sketch and stick with the geometry, and those are called persistent relations. Those are probably the closest thing we have to constraints now in the sketcher. So you can display those, you can hide those, kind of like you can do with constraints in the legacy sketch. But those are going to be displayed automatically when you're working with the show movable command, so that you can clearly see if there's any constraints any relations that are conflicting with any dimensions. So I'll try to show that. I know in a lot of words it might not make a lot of sense. I'm going to show that. Now the rectangle command, that's been enhanced for 2306, so that if you use the center option, once you create the rectangle, you'll see a center point as well as a diagonal line that you can use to manipulate the rectangle. So you can constrain those elements. You can constrain to the midpoint there. You can constrain to that diagonal line. And you can also click and drag those around on the sketch to manipulate the orientation and size of the rectangle. So it's pretty easy to use. You'll figure it out right away just by playing around with it. And then another command that I'm going to show you here is being able to reattach a sketch. The reattach command itself is not new, but the way it worked prior to NX 2306 was that you had to go into the sketch. You had to go into edit mode for that sketch, and then the reattach command was up on the sketch toolbar. So here in 2306, you can really just go into the part navigator, and you'll find reattach sketch offered to you as an option in the context menu. Just right-click on the sketch. So you can do that without having to go into the sketch edit mode. Another nice thing is you get a preview. I think we talk about that, in the next slide here. You get a preview so that you'll see what the result of your sketch is before you commit yourself to actually reattaching your sketch and watching the model update and maybe fail if you missed something. So let me jump back to NX and I'll try to show these to you. So I'm just going to go ahead and create a new part here and try to show the, just start off with a fresh part. All right, so first thing I wanted to show is the show movable command, how that works here in NX 2306. So I'm just going to create a sketch. Let's put it on the front plane there. And then I'll create a profile. So I'll just start at the origin. And let's create kind of a classic L-shaped bracket that we use often in our beginning NX class, training class. So there's our sketch. I don't really need to do any sizes yet here, but let me go ahead and talk a little bit about relations in case you haven't worked with this before. So we've got our relation toolbar up here. It's going to look suspiciously familiar to a lot of geometric constraints in the legacy sketch. In my toolbar, I've got an option turned on over here to the right, which, if you're playing around with NX as I'm talking, you might not see this, but if you go into the drop-down toolbar, it's right here. It's called Create Persistent Relations. So I'm going to turn this on and activate it. So you see it's shaded in blue, just so you can see the relations that I'm going to apply here. So I'm going to go ahead and select multiple lines here. Let's make them persistently vertical. And then I'm going to select these three horizontal lines, and let's make them horizontal. Now, you don't see the relation symbols showing up right now because there's an option here that will display those. So now you can see these show up. So there are differences between found relations and persistent relations. Again, I'm going to leave that to the sketch session to get into detail about those. So I'm going to turn these back off again, so you can't see them. So let's say my design intent changes and I want to be able to change the angle of this L shape. I don't necessarily want to limit it to 90 degrees. I want to be able to modify that. So I'm going to go ahead and put a dimension here. Notice in the new sketch, there's no dimension icon. I just simply select my lines in my sketch. I get a dimension I can play around with here. And with the show movable command turned on, I'm going to get some messages about having a conflict. So I've got some, again, horizontal and vertical lines that I've defined, as well as my angular dimension. I'm going to get an alert down here. It says this dimension can't be edited because it's going to overdefine the sketch. So let's go ahead and make this an expression. And here's what you'll see. So when you start to work with expressions in your sketch, and if there's any conflicts with some of these persistent relations, they're going to show up in the red. So if you're working with the legacy sketch now, that should look pretty familiar to you. Now, when you turn off the show movable, in the new sketch environment, the sketch is not evaluated. You see this message down here in the bottom of the graphics window. So that's what show movable does. It evaluates your sketch, so the sketch solver is continually searching and trying to solve what's been created here and what relations and dimensions are applied. I'm going to go ahead and turn off the display persistent relations button, because the show movable command, if there are any conflicts in your sketch, it's going to turn that switch back on automatically for you, so that you can clearly see what might be causing some issues here. So that's one of the enhancements with the show movable command. One of the other things that I think we were talking about was the rectangle. So let me show you the rectangle command. Again, this affects the center option. So I got to switch my toolbar option over here to the from center option. So let me go ahead and select a center point. And if you're familiar with this, the interaction really hasn't changed much. You still have to define your kind of primary length, and you can go either way, right or left. And then once you select that length, you got the height to define. So that hasn't changed, but once you click that final point there, here's where you get your center point and your diagonal lines. So if I select the point here, you can see I can use this to change the size. So I'm just clicking and dragging. If I select the line, I can drag the whole rectangle around on my sketch. And of course, you can dimension to these. So if I go ahead and select that line, just not click and drag, but just click, then I can either use some of the dimensions that are given, or if I continue to select another reference line here, now I've got an angle that I can adjust. So you can use those extra elements in the sketch for that rectangle for dimensioning and defining purposes. So that's the rectangle. So one other command I wanted to show is the reattach. Let me get out of this, and I'm just going to switch back to my previous example here. It'll be a little easier to see what I'm doing since I've got a model built from this. So to reattach a sketch, we don't have to go into the sketch mode anymore. So just right click if I want to reattach the the primary sketch on my model here. I could just simply right click and choose reattach sketch. It's right here in the context menu. So choose reattach sketch. This dialog is the same as it was before. You have the ability to redefine a sketch plane, a new, we call it horizontal reference, the sketch orientation, as well as an origin point. So those three things are currently defined. You see them highlighted out here on the graphics. So I'm going to go ahead and respecify a plane. So let me go ahead and select a plane there. So I specify a new plane. You can see the normal is going off to the right there. So let me, I'm sorry, the orientation is going off to the right. And the alert down here, it just mentions that my horizontal reference is actually right now, it's perpendicular to the new plane. So I need to specify that horizontal direction. Let me go ahead and select that. X direction looks like I've got my Z going off to the right. I don't want it going off to the right, so I'm going to go back up here and reverse the direction of the plane. And my origin point is fine. I'm not going to change that at all. So you can see some of that just simply from the references. Another new enhancement here with NX2306 is that you can click the Show Results button, and it shows you where that sketch is going to go. So I could have made use of that if I didn't realize my sketch normal was the wrong way. So let me flip that around and click Show Result. See where my sketch goes? It's upside down. So I think that's going to be a pretty handy enhancement to the reattach sketch command. So let me reverse my normal, show result again. That looks fine. I'm going to go ahead and click OK. So now you see my part follows the sketch, and my sketch has been reattached to the XZ plane. Let's see. So that's a quick run through some of the sketch enhancements. One thing that I'll just talk about here with the time that we have is that when you're working with fillets in your sketch, when you go through and try to maneuver your sketch, click and drag different lines in your sketch. If there's a fillet between them, you'll see a little blue dot shows up, and NX finds that relationship, that fillet relation, so it maintains the tangencies. If you move the lines, you'll get that fillet to follow and remain tangent. So it's kind of a different look there. So I just want to mention. Let's get into a couple modeling enhancements. I think some of these are pretty exciting. The first one there with putting a hole through multiple bodies. I think a lot of folks are familiar with the whole series option in the whole feature, in that dialog where you can put a hole through multiple parts, like in a stack up of plates in a mold assembly. This command really lets you do that type of operation within multiple solid bodies within a single part file. So that's something that's new. The second one here is a little bit difficult to explain in words, but it lets you position your cursor. It's like a quick pick enhancement. You can position your cursor over a piece of geometry which may have been derived from a trim or a Boolean operation, but you're really trying to find the original feature that defined that. Let's say it's a blend, for example, and you want to edit that. Sometimes it's hard to find. The selection enhancement makes it a lot easier to find. I'll show you how that works too. So here's the first one in the hole command. When you work with threaded holes, you can put those through multiple bodies within the same model. So this is not an assembly. I'm talking about a single part file. And this also carries over into drafting. That's one of the enhancements that I'll mention a little later on. So if you've got multiple bodies that you're putting either one or more holes, threaded holes through those bodies, and you want to represent those on a drawing, all of that's supported now. Well, I'm going to show that. Let me just go ahead and show that right now. It's going to be pretty quick to show. So let me open up another model here. So here's a cylinder with an end cap. They're spaced out here just so you can show they're clearly two different solid bodies. Again, this is one model. This is not an assembly. This is one part file. And I'm going to go ahead. Let me open up the drawing too. So let's go into the hole command. Nothing new at the beginning here. It's kind of a subtle change down here at the bottom where I can actually choose multiple target bodies to subtract from. So I'm going to set that to threaded. It's already set to threaded. Let's go ahead and put a hole over here. So I'm going to put one on this flange. Let's put it up here. And I'm going to go ahead and center this thing up. So I'm going to set the horizontal dimension to 0. Let's set that vertical dimension to 64. I just kind of like some nice round numbers. So here you can see the preview. So I've got a hole that's going to go through the first part, span this gap between the two, and then go into the second part. Now, if I want to make sure that that hole gets applied to both parts, I need to go down here to the Boolean section. You can see that the first solid body where the placement point was, it finds that one. If I want to apply that hole to the second one, I just need to make sure I select that one. So we've got two targets, and I'll just go ahead and click OK. All right. So again, to kind of prove that that's threaded, that's why I opened up the drawing. If I go and update the drawing, okay. All right. So there are my threads. Now, this behavior does carry over when you pattern that hole as well. So let me just do a really quick circular pattern. So I'm going to do a pattern feature and select the hole. So see, that's one feature. It's not two separate features. It still maintains a single feature definition. So we're going to do circular. Let me specify vector. I'm just going to go ahead and select that outside face there. So you see I've got 8 instances here. So let me go ahead and click OK. So you can see that pattern again. It applies that hole to both parts in every instance of that pattern. So then I can go over here to my drawing and let's update this. Hopefully I didn't make a boo-boo there, and it looks good. So there's my threaded hole. All right, so there's the first one. So let's go into the second enhancement I wanted to cover on the modeling side, and that's with this select geometry command. So with select geometry, you can go ahead and put your cursor over some faces on the part, and you get your quick pick that shows up, and it'll actually show you the original feature that was used to define that particular face, and it makes it easier to go and identify that feature for editing purposes. And I think this is going to be really helpful. So just coming from someone who gets a lot of customer models, I get things sent to me, and I am asked to help resolve certain issues. Just being able to find the features faster is a real big help. So here's an example. Just think of this as a mold or a die or something. So we've got a part that was designed and subtracted, maybe linked. There's a link body and subtracted from block to create a cavity. So if I wanted to edit, let's say I want to edit this blend right here. I'll go ahead and put my cursor there. You see the 3 dots show up, so I get my quick pick that shows up. And then up here in the list, you see where it says original. That's the original feature that defined that shape. If I go over to the left here and, oops, let me get out of there for a moment. I'll show my model history there. Let's do that again. So I can just either select it right off the bat. You see it's highlighted over there on the left in the blue. Even out of the quick pick, I can right click and choose either edit parameters, edit with rollback. Goes back to the original feature there. I can go ahead and change that blend, click OK, and then it updates and shows me that new the new size there. I'll do another one over here. So let's go in and maybe I want to change this radius right there. So I'll put my cursor here, wait for the quick pick, or you can use select from list. You can see now that was created from a hole, which kind of seems kind of weird because it's a cylindrical face there, but let's go ahead and edit that. So you can see that was done with a hole. And I'm just going to change the size so we can grab that again. Oh, it's a formula. Let me change that. Okay, so let's make that a little bit smaller so it's noticeable. Click OK. There's the result. So again, I think that selection enhancement makes it a lot quicker to go and make some edits. Otherwise, you have to go through the model history, take a look at the dependencies of the features, and maybe kind of browse your way back to the original feature where that geometry might be defined. So we got a few more minutes left here. Let's get into assemblies. A couple different things. I'll talk about the new assembly constraint interaction. So instead of working with a toolbar, you'll be working with constraints for assemblies that are presented right there in the ribbon bar. It's a more guided approach to applying constraints, and you'll see what I'm talking about when I do my demo. The second thing I want to show is some of the enhancements for how the simplify assembly command works. In that, you have some automatic, let's just say, face selections of different kinds to be affected by the simplify command. So the first thing I'm going to show here is the interaction for constraints. So there's a consistency involved here where when you apply your constraints, you're going to be asked to select geometry from the part that's going to move. That's the motion object. And it's going to move towards the second part, which is going to be stationary. That's going to be the stationary object. So it's always a from to type of interaction. So for the most part, the constraints are still the same. They're just presented a little differently, and your choice of selection is going to be, I guess, directional if you want to call it that way. But let me just show that to you so you can see what it looks like. I'm going to open up an assembly here. Let's open up this. So this is just a simple assembly with a bunch of parts kind of scattered about that we use for examples like this. So let me go into the assemblies toolbar. So up here you'll see in the position group, this is where all of your constraints are going to be located now. And let's just kind of take a look at how these work. So if I wanted to put, let's say I want to put this blue part on top of the green part and line up that slot in there. So I'm going to go ahead and do a touch constraint. So touch and align have been pulled apart here. And you can see here's the interaction. And this is going to be consistent through all of these constraints. Select geometry from the motion object first, then geometry from a stationary object. One thing that you'll notice, if I can get over here, let's see, turn my constraints on. There is no fixed constraint on the green part yet. That's going to be my stationary object. So we've always used to tell people, fix your primary part first, and then apply your other parts with constraints to that fixed part. You don't necessarily have to do that. You can come back later on and fix any particular part. So you have a motion part. So let me go ahead and select the underside face of the blue part and the top face of the green part. And you'll see if I position this properly, you'll see it move into position. So there's a touch constraint there. So let's do a, let's see, that one's fine there. So let me go ahead and do another touch constraint. I guess I didn't need to close that dialog. And again, I'm going to go from blue to green. So I'm going to select the face on the back side of this tab and select the inside face for the stationary object here in this slot of the green part. So you see those two move together. And then the last thing I'm going to do here is I'm going to use a center constraint because this is one constraint that doesn't use that terminology. It just says first object, second object. I'm sorry, set one, set two. But it's still motion versus stationary. So for set one, I'm going to select two faces on the motion object. And then for set two, select two faces on the stationary object and have those go together. So that's how the new constraint interaction works. So it's always a from to motion to stationary. Okay, the next thing I want to show, it looks like I'm actually running a little short on time, so let me run through this pretty quickly. So for the simplify assembly, this is an older, as you can see, it's based on 2212, but I think it's something that's kind of worth talking about if you haven't used simplify much recently. So with the simplify command, you can create a simplified representation of your assembly either in the same file as the assembly, just as separate solid bodies, or you can save it as a separate part file. And then it doesn't show that here, but if you go through the dialogues, you can choose to include blend faces by size. You can choose holes by size. So just let me go ahead and show you what that looks like here. So I'm going to open up an assembly and try to run through this. So let's go to the assemblies tools. Now simplify is over here. I probably should have mentioned earlier that if you don't see all these commands on the assembly toolbar, chances are you're not using the advanced role. So over here on the resource bar, if you look at the roles, if you're trying to play around with this as you're listening and watching, if you don't see all of these commands out here, just make sure you're in the advanced role, and that way you'll see all these commands. So let's go back in here and let's use simplify assembly. I've got my dialog set to create the simplification in a new part file. So I'm just going to go ahead and use the model template for that purpose. I'll show you where this is, which is right here towards the top. So where do you want your simplified part to be? In the new part or in the current assembly, or do you want to put it in yet another part? So let me just kind of really quickly, I don't need to do a whole lot. You can see the preview over here on the right side to get the split screen. So let me move this dialog so you can see what's happening. So you've got some rules for removing small bodies. Right now it's less than or equal to 1.3 inches, and you can see I've got some of these small screws there. Let me show you what happens if I change this a little bit, make this a little bit bigger. Let's update the preview. Oh, I guess that's not big enough. Let's make it 2. Yep, so you see those disappear over here on the simplified version. So you've got removing small bodies, you've got removing internal bodies. So if there are parts inside this assembly that we want to get rid of, like you see, you can maybe make out that there's a connecting rod in here, there's a cap, and there's some screws down there. And then you've also got body simplification rules for removing holes by size. So you might see that there's some holes in this pulley that are missing from the simplified version, as well as blends. So you've got blends that are selected by size again, and you can see there's some sharp corners out here on the simplified version. So just click OK, and we've got our simplified assembly on the right side, the original assembly on the left side. So again, I've saved this or generated this as a separate part file that we'll save. This drafting, we've got automatic symbol sizing for the balloons. These callouts here that have the symbols. A lot of times when you change the text size, it's not tied to the balloon size, and you have to modify those separately. So there's an option here for turning on automatic symbol size. You change the text to symbol size, adjust to accommodate the text. See that in the dialog as an option. Again, kind of going along with the threaded hole through multiple bodies, the callouts support that as well. So if you've got a threaded hole like I had before that goes through multiple bodies in the same part, when you put that on a drawing and you use the hole callout, it does span across the multiple bodies. So the last thing I want to talk about here, and thank you for kind of sticking with me here. There's a lot more enhancements that you can find information for. One way to get that is to go to the Siemens Support Center. You do have to have a web key address, but you see the URL here. It's really just support.sw, software.siemens.com. Chances are, if you just put that address in, it'll take you to the English page if you're here in the US. There's also the NX help that you can get to. And a lot of stuff is available right there in Discovery Center. Let me get NX back on the screen. If I go to my Discovery Center, so in Discovery Center, a lot of people just kind of blow past this because they're so eager to get into working with NX that you don't notice maybe that there's a What's New button up here. And you can use this to filter through different applications of NX. So if I wanted to know what's new since NX 12, and this gives you a list of all the progressions of the versions here, but NX 12, and if we just want CAD or if you want CAM, I'll leave that for another session. So let's look at what's new in design, and if you are looking for what's new in, let's say, drafting. So drafting. So this is a real quick way to go and see what's new. You see, there's a lot of enhancements since NX 12. If I just go from the most recent release, 2212. Let's go and take a look at drafting. See, there's 3 enhancements there. We go into modeling. See, there's a lot more enhancements there. So again, there's not enough time to cover everything. Just wanted to make sure that you saw where to go for more information. But I hope you got some good information out of this presentation. If you, again, want to get hold of me and ask any questions that might come to mind later on, here's my contact information again. Feel free to email me or give me a call. So thanks for your attention, and hope you have a good day. Thank you.
In this presentation, we're going to be taking a look at model-based definition and PMI. A little bit of background about myself here. I'm Michael Pinto. I'm an application engineer here with Swoosh Technologies. I do teaching. I also support our customers here at Swoosh. I have over 24 years of experience designing products with the Siemens NX software. My background is in the aerospace industry as well as with consumer goods. I work for various companies such as Pratt & Whitney and Nike throughout my career. I do enjoy teaching and supporting our customers in their pursuit to achieve the best possible designs while they use the Siemens software products. My expertise in 3D modeling, advanced surfacing, freeform modeling, model-based definition, and PMI, which you're going to be looking at here, as well as assemblies, drafting, stage modeling, and many other areas of the CAD part of the software. You can see my contact information there. If you have any questions after the presentation, feel free to reach out via my email address there. You can also snap a picture of that QR code to save a copy of my contact information. Getting into our agenda here, we're going to take a look at what is model-based definition. Take a look at PMI capabilities, model-based definition capabilities, downstream uses for PMI, and then we'll wrap it up with a quick summary and also look at licensing requirements to use the model-based definition and PMI inside your NX software. Getting into our first discussion here, what is model-based definition? So inside the Siemens NX portfolio of software products, you'll see that the model-based definition falls within the mechanical side or realm of the software. Now, NX model-based definition is going to deliver advanced capabilities that support model-based definition deployments and connecting engineering and production with breakthrough innovations here. NX Product and Manufacturing Information, or NX PMI, that's going to enable the production of a complete digital definition of a product within your 3D model and eliminates the need for traditional drawings here. Not to say you can't still create those traditional drawings, but you can create the embedded information on your physical models now, and that model becomes the source of truth. Looking at the overall diagram here, we can see where PMI fits into the scheme here in the relationship to model-based definition and what's referred to as MBE, or model-based enterprise. The smallest circle in this diagram depicts the product and manufacturing information, which is known as PMI. This is all the non-geometric data that is applied to a 3D model that's going to convey information about that design and help to convey how to produce and manufacturing that product. Now, if you look at the second or the middle circle there, which is representing the model-based definition, this is the practice of producing a complete digital definition of that product within a 3D model, and it includes the geometry, the PMI, and all the metadata involved in that model. And then if you look at that largest circle, you can see here, that's going to include the PMI model-based definition inside of this model-based enterprise. That model-based enterprise is the process of reusing this model-based definition by downstream consumers across your entire enterprise here. So when we think about using a physical digital model with all the embedded information on that and passing that off to a different team member, and they can use that same information inside their part of the job, might be setting up some CNC operations here, maybe setting up for some inspection programming, etc. Getting into what is PMI here, a model-based definition, that is the complete digital definition of that product within your 3D model. That PMI is the actual product and manufacturing information, things such as your dimensions, GD&T applied to the part, different areas that you can mark off on the part, security markings. So this is going to convey the information such as geometric dimensioning and tolerancing, those 3D annotations, surface finishes, and material specifications on the part. This is going to allow for the manufacture and inspection of the product without the need for those 2D drawings. Value of this application of the PMI on your parts, that PMI is going to allow digital data to be reused by parallel product development processes, because that data is going to be inside the actual model here or embedded on the physical model, physical features, and it's going to communicate information about the physical features of that part. Now, what does this do? This adds great value to your models. You can reuse this embedded information, and you can use that across various applications within the design enterprise here. It's also going to utilize cost-effective and low-risk JT-enabled collaboration within the entire supply chain. You can apply that to a work instruction here. And if you look at the diagram down below at the center, we have an automobile door. And you can see once we've applied the PMI and that model-based definition to that automobile door, we can take that and reuse this data across these various other areas of our enterprise. So we can do part planning and NC manufacturing operations. We can create those work instructions, set this up, and send this out for variation analysis to do those types of stack-up analysis on our assemblies. Also, we can do assembly process planning, and CMM inspection probing paths can be automatically generated by reading this embedded PMI information on that part. Now, if you look over on the left, you'll see that PMI-driven machining reduces NC programming time by up to 20%. Applying this type of important PMI information or model-based definition to our products, not only is this adding a lot of value to that model, it's also going to be leveraged in these other operations to help you save time downstream as well. Taking a look at leveraging the shared representation of the model-based definition on your parts, benefits of a model-centric solution, you can see with that particular part in the center there, we can take that model, embed all the information on it, and just like you saw in that previous slide, you can see we can reuse that information and all these other applications throughout our enterprise. This is going to reduce cycle time by avoiding data transfer. It's also going to increase innovation through the ability to rapidly explore more design variations here. We can also avoid the redesign by validating manufacturing errors early in our development process. We can also have a master model that's going to enable production changes without disruption here. Taking a look at the model-based definition leading up to the digital twin, this is a term where we're creating a digital twin of a real-world product here. This digital twin has all the important information embedded in that model. Now, if we look over on the far left, this is a breakdown of what was life like before model-based definition, and we can take our journey going from a drawing-based type of a setup inside of our CAD software all the way up to a model-based enterprise here. So starting on the far left, you can see the traditional way that we used to create these products, creating a 2D drawing. We had a drawing-only based setup here. 2D is the primary deliverable, and therefore the drawing is the master. This is the source of truth. There's room for error there because somebody can go in and manually edit a dimension. Somebody could pick or create a dimension going to the wrong edge, and now you have the wrong information being communicated downstream to manufacturing for this part. If we look over to the right of that, the model-centric based setup, this is a drawing from model with or without associativity. So we create that 3D model, we generate the drawing, and we read or create the dimensions going to the drawing view edges, things like that inside those views. But there's still a large area of human error that could take place here. So the drawing is going to remain the master or the source of truth here with the model-centric type setup here. If we look at the next option over, model-based definition, now we're getting into the discussion of embedding this information on the physical features of the model. So once you start to embed the PMI, all that model-based definition, your dimensions, different GD&T callouts for those features, surface finishes, security markings, etc., now we're applying this information to the physical features on the model. So this model contains product and manufacturing information. It completes that digital definition of a product within a 3D model, and the deliverable includes technical data packages as well. Now the model is the master, that is the source of truth. The benefit here, if the model changes, the features change on that model, this is all communicated downstream to our other operations throughout the enterprise. Going over to the far right here, the model-based enterprise setup, that's going to complete our downstream model reuse. So we're taking that physical model that has the embedded model-based definition PMI on it, and we're going to reuse that 3D model by all the downstream consumers across our enterprise. The model is the source of truth, and if something changes on this design, this model, all the PMI is going to update accordingly, and that will propagate downstream to the other operations at the enterprise. Taking a look at item number 2, or topic number 2 here, PMI capabilities. Looking at the NX or the Siemens NX model-based definition portfolio, we have on the left-hand side our NX product and manufacturing information, or our NX PMI. This is the application or the capability to add the physical dimensions, GD&T, all that important information to the model and to those physical features on the model. If we look over on the right, NX model-based definition, that's going to deliver the advanced capabilities to support model-based definition deployments by connecting engineering and production with breakthrough innovation here. Now with the NX MBD, there are a lot of different tools we can use here to help us once we apply the model-based definition or PMI to the part, where we can run some items or advisors, such as the PMI advisor inside the software, and it's going to help us to interrogate the model based on the PMI that's applied to certain features on the part, and it's going to either flag those items, as you can see in the image there with a green check mark, if that passes based on the standards we're applying to our design, or if something needs to be reviewed, you'll see maybe a triangle there with an exclamation point, and you'll also see a red X or some items with a red X indicator. That's going to be an item that is not passing or failing based on the standards we're applying to our part or designing our part 2 here. Getting into the comprehensive 3D annotation tools, with PMI we can create dimensions, annotation, specialized objects, different security markings, supplemental geometry. We can run searches and reports. We can also do sectioning and mirroring of our parts. So sectioning, of course, cutting through the part so we can detail those important interior features on this product, as well as the capability to wavelength PMI from one level in the assembly up to another level, maybe the top level of the assembly, and reference that PMI information in that level. Now getting into the standards for our 3D annotation, well, you can see we have 2 standards here, one being ASME Y14.41. This is a 3D digital product definition standard for the ASME standard. You can see we also have an ISO standard, and that is the Digital Product Definition Data Practices, and that is ISO 16792. So these 2 standards are built into the NX product, and you determine what you want the software to check or what standard you want to design your product to. The PMI advisor is going to check that PMI that's applied to the part based upon these standards. Getting into our dimensioning and annotation, you can see just like with a traditional style drawing, we can use the traditional methods for creating these dimensions on our parts. So we can dimension our widths, diameters, heights, etc. to start to define the overall size of these features on the part. We have a comprehensive dimensioning and annotation capabilities, and we can fully define that geometry, and we can add tolerances just like you would on a regular drawing. It's fast and easy to create these items. We can reuse those features and sketch dimensions. Also, we can utilize multi-CAD data with PMI embedded JT. This is also standards compliant, so based on the two standards we spoke of a moment ago, we can use those standards to help us have the software run some checks and ensure that these are being applied to the features correctly. We can also capture, display, and consume PMI objects in a tabular format if we need to do that. If you look at the toolbar there, you'll see that those toolbars with the PMI toolset are going to be nearly identical to the toolbars you're going to see creating a drawing in the drafting application inside of the NX product. So you're going to have familiarity right there, and you're going to be able to get right into using these PMI tools, using those tool sets, and get right into creating the PMI on the physical models inside your designs here. Taking a look at our next type of PMI, we can apply these supplemental geometry items, such as our bolt circle center lines, and we can go ahead and create full and partial bolt circle center lines. PMI regions, we can go ahead and apply a PMI region to the part, whether we want to limit the application of a tolerance, or we want to maybe mark off an area on the surface there and tell somebody that we're going to keep an area here that has no paint in it, or a different finish in that area. Additionally, we can create sections through our parts very easily. We can use the PMI sectioning tool, cut a section through the part, so we can detail all those important features on the interior of our design here. We can easily mirror PMI and model views. That's going to allow us to reposition, delete, and hide as well. And we also have what's called the Wave PMI linker, and we can go ahead and link PMI to geometry and other models here. So this is nice because we can link PMI. If we have a note that's at a sub-level component, we can link that and link that up to a different level in the assembly, all the way up to the top of the assembly if we need to do that and reference that. Getting into a quick demo here, we'll take a look at some PMI capabilities in the software. All right, so we're going to open up a part here, a simple little assembly here. So we have a cam assembly, and we're going to focus on the main cam box part here in this demonstration. So opening up that part, making that the work part here, we're also going to open that up in its own dedicated window. So let's go ahead and open up our cam box in its own window, and we'll create some PMI on that part. Now that we have our cam box part open here, we can go ahead and take a look at our tool set. So the PMI application is a dedicated application inside the software. If you don't see that toolbar turned on, or that set of tools turned on, you can go into the applications here, go over to the document group, and turn on the toolbox drop down here, the PMI option. This is an additional application to author the PMI, so you do have to activate that and turn that on in your NX session here. Once you turn that on, you'll have your PMI toolbars and all your different PMI tool sets on that toolbar. Now we have a dedicated model-based definition navigator on the resource bar. That's going to contain all your PMI views and your PMI once you apply that to your parts. With that model-based definition navigator, we can easily navigate through our preset views here. You'll see that we have a standard category, but we can also create our own group and add a new view set here. So we'll select the Add View Set, give that a name, and the name input fields here. And now we're going to choose some views to add to that PMI set. Once we create the PMI set, you can see in our model-based definition navigator, there's our view set PMI set 1 and all the views that we added to that set. If we double click on one of the views, we can activate that as the work view, and then we can begin to add some supplemental geometry to our part. So I'll add a center mark here across one of the holes, and then add some additional center marks on additional holes here on the design. All right, next we can come up and create a rapid dimension. Just like you would with your drafting application, we can create a rapid dimension using the rapid dimension tool here, and we can quickly create some dimensions on the part. So we'll go from the center of the part over to the left smaller hole there on that top surface. And you can see on the dimensional pop-up, we can quickly adjust things here and create a basic dimension there. Additionally, we'll create the second dimension over to the opposite hole on the opposite side of the part. And we'll create a vertical dimension down to the bottom of the part and up to this center mark here. Now we'll add some radial dimensions, just like you would in your drawings, but now we're applying that to a 3D model, of course, with our PMI. As you can see how easy it is to adjust the dimension once you apply that to the part. We can add some tolerance and place that where we want that in the environment. And now we'll go ahead and add a whole call out here. And as you can see, when you do click on the hole, it's reading the information from the feature. So we're getting that M6 by 1, 6H, 20 deep call out there. It's actually reading the information from the feature. And we have 3 additional holes that are identical here. So we can go in and add our appended text on the front side if we need to do that. So we can put 3X here and quickly designate we have 3 of the same identical holes here on that top surface. Now we can take a look at our section view. So PMI section views can be created using our section tool on the PMI toolset. All you have to do is activate that. We get the pole handles here, and you can interact with those handles or that coordinate system to change the cutting plane location on the design. Use your snap points to pick up on different locations and relocate the cutting plane very easily with that tool. We can change the angle here if we need to do that. And if you're familiar with the view or the section view tool, this is almost identical here, and you'll be able to jump right in and use this tool and be very familiar with that. So in the cutting plane symbol here, we can also display the cutting plane symbol inside the 3D environment, and you'll see the arrow that was just added to the top right corner of the cutting plane. We can also add the letter. You'll see that when we're completed here with the operation. The section view text can be adjusted to correct the view letter as well. And we also have some additional options here to change the color if we want to do that. And then additionally, we're going to go into the settings next here, and we can also display a second arrow on the bottom left corner of our cutting plane if we'd like to do that in the graphics display. Here's the first letter with the arrow, but we can also turn on and use 2 arrows if we'd like to do that and have those displayed in our display here. Now the PMI section views are going to be saved in the model-based definition navigator. In that model view section, you'll see there's our section 1. We can easily activate that as the work view. When you're creating PMI, you want to activate that as the work view and then create your PMI so the PMI goes to that view or is related to that view. So we'll go ahead and add some center lines. We'll pick up on all these surfaces here. The nice thing about PMI is you're selecting the surfaces. Therefore, that center line is related to all those surfaces, which tells the user that those are axisymmetric types of surfaces on the part or features on the part. Apply a few more dimensions here, and then finish that part. All right, so PMI created on the part will show up in the model-based definition navigator and can be added to any of the views inside the part. If you need to move those to another view, you can just go ahead and select all those items or the items you want to add to a different view. Right-click on that, go to Display, and you can choose the views here that you want that PMI to show up in. So there's our PMI set 1, and we added that to an additional view here. Very easily, you can move the PMI or display that PMI in different views on your model. Now, datums and feature control frames can be added using the PMI toolbar, and we'll go ahead and demonstrate that next. Up here on the toolbar, you're going to see your feature control frame option. We'll open that up, and now you can begin to create our feature control frame and apply that to one of the features. Now, when you do activate the feature control frame, the entire ribbon bar is going to switch over to give you access to all the tool sets here to customize that feature control frame with all the appropriate settings. You can apply your datums here, primary, secondary, and tertiary, as well as your modifiers and all the other types of feature control frame settings inside that toolbar. Now, as you see, there is a direct relationship with that feature control frame. We referenced datum A and B. You can see when we select that feature control frame, A and B are highlighted on the part. Now, PMI can also be inherited from the model into the drafting view, making drawing creation faster and more efficient here. So if you're still going to stick with that drawing practice, we can use this information over again inside our designs. So we're going to go ahead and enter the base view settings first. And now we're going to go ahead and add the PMI. So on the PMI section here, Activate that over in the right-hand panel, hit the drop-down, and we're going to inherit that from the model view. Choose your type to inherit, and then go ahead and select OK. Place the view on the drawing sheet, and your PMI is inherited just like that. So you can still use that traditional drafting practice if you need to do that and reuse your PMI there. Now, the next thing we'll look at here is what's called a technical data package, and we can export with embedded models all of our PMI for full interactivity. As you can see, we have all of our PMI outlined over on the right-hand table. You can change the drop-down, pick on your feature control frame. What's nice about that, it's going to change that to that view that PMI feature control frame is at. Complete interactivity here. You can rotate those views around just like you would as if you were in a CAD application. This is lightweight JT geometry we're looking at here, but this is in just a PDF document format. All right, so that's PMI capabilities. And getting into the next discussion here, item number 3, we'll be looking at NX model-based definition capabilities. All right, looking at NX model-based definition, key features here. We're going to take a look at automated authoring of our PMI, capturing key characteristics and knowledge, PMI advisor for validation and guidance, also direct consumption of our model-based data. Now, this is a patented technology. Siemens does have patents related to the PMI. Also, it is an industry-first solution that delivers significant productivity gains for repeatable and predictable processes on your designs. We do have rules that do more than speed up authoring of the PMI. These rules are going to enable a user to capture more intelligence in the model. We can apply default tolerance, lookup tables, associative pattern counts, updates, etc. So using these rules are going to save you a lot of time. When you have a complex model, run one of those rules and it can quickly interrogate that model and apply some of these different PMI to the part very quickly. These rules are not going to be part specific. We can create a rule. We can use the out-of-the-box rules. Siemens does provide over 100 plus out-of-the-box rules for the user to take advantage of. You can open those rules up. You can learn from those and create or customize those rules and create your own rules and your own library here. That way we're creating these rules and we can reuse those over and over again. We can share those with our colleagues and they can use those rules, saving a lot of time in the future. All right, the PMI Advisor. This is a fully integrated PMI validation solution, and it's going to provide notification verifying whether PMI is going to maintain the compliance with industry or company standards that you're designing your parts to here. This is going to ensure for the production of your higher quality parts and a lot less time. Also, it's going to provide guidance or corrective solutions. That's going to remove that dependency on highly trained GD&T experts. So if you have somebody that's new to the GD&T process, applying GD&T to parts, this PMI Advisor can help those new users to learn how to apply PMI to features and do that in the correct manner here. You're going to see in the demonstration, when you do apply PMI to the part and then run the advisor, it's checking to the standard that you prescribed or told the software you're designing the product to, and it's going to start to flag the PMI with a green check mark, a yellow triangle there with the exclamation point, or you'll see a red X on some of those features if they're out of compliance. So notification options include creating, editing, and post-author workflows here. Flexible configurable checking modes where we can advise and enforce, and we can also support multi-CAD validation requirements here. There are 400 plus advisor checks with support for custom checks as well. Getting into our demonstration of the automated PMI authoring and PMI advisor now. Taking a look at this part, you can see we have a complex part here, a lot of internal features on this design. And now we're going to demonstrate and show you how these rules can be used to author PMI on your models here, especially these complex designs like this. So we do have a rather complex part, but we're going to use a PMI rule to help us apply the PMI. We can use our PMI interactive toolset to do that, or we also over on the right have the rule category. On the rule category, you're going to see we have instance, define. We also have some of those different types of PMI rules that we use quite frequently here, and you can save those on the toolbar so you can easily get back to those and run those if you need to do that. So we have an instance or insert instance and a define option here. The define option is going to let you create those rules in the logic editor environment, but we also have frequently used PMI rules on the toolbar here as well. Gives us easy access. If we have those rules that we use over and over again, we can apply those to the toolbar. Now I can just go up and click one of those rules and run that on my design. Looking over in the reuse library, this is where the logical rules are going to be placed. We can expand the logical rules, and you're going to see there's 100 plus rules out of the box that Siemens provides for the user here. We have many different categories: automation, datum, dimension, feature control frame, model view, note, surface finish, technical data package rules here. But we're going to go up to the datum rules. And inside that folder, you're going to notice once you select the folder, down in the member select area, it's going to reveal the different rules for that category. So we're going to use a rule that's called datum across faces. And what this rule is going to do is it's going to allow you to select one face, and that is going to allow the software to interrogate the part, and it's going to find all the coplanar faces with that first chosen face by the user, and it's going to kind of create those or associate those all as being the same datum. So here we'll select a surface, select that desired face on the part for the datum. The create across faces rule is going to interrogate the model, and it's going to find all the coplanar faces with the first chosen face there and generate or treat those all as datum A in this case. So once we select the datum A icon out there in the graphics display on the part, you can see it highlights all those additional surfaces because it referenced those and recognized those were all coplanar with the first chosen face there. If you had to do the same thing without the rule, you would have had to find all those coplanar faces and select them all manually. So as you can imagine, just this little example here, the time savings you'll get just by reusing these rules over and over again is going to be a large or a great amount of time. We can select the face to move that, and we're going to make a change in the model and move this face out of that coplanar condition with datum A. Select OK. And you're going to see how easy it is to update these rules and rerun the rules on your parts here. We can go back to the model-based definition navigator, go to our create across faces rule here, and we can go ahead and update that rule on the part. So we can right-click on the rule and we can update that. It's going to reinterrogate the part, and it's going to recognize that we moved a face out of the coplanar condition and remove that from the datum A selected faces there. Once the part updates, we select datum A. Now you can see our previously moved face is no longer part of that coplanar group of faces, therefore it's no longer considered part of your datum A. All right, getting into our reuse library again, we'll apply another rule from that reuse library, and we'll apply a feature control frame rule to create positional tolerance on our features here. So going into the feature control frame folder, we'll choose the create position rule, and we'll designate a tolerance here. We can customize this rule if we need to. Nice thing about these user interfaces, when you customize or you build these in the software, they're very user-friendly with drop-down menus, etc., to choose different options here or input fields to change, in this case, the tolerance value. So once we create this rule, we'll create the position from datum rule and go out and create all the position tolerances on this part. Now, NX is using feature recognition to locate the size of the holes and then group them individually and define our patterns for those holes as well. As you can see, you'll see there is potentially a 6x or a number X that's telling the software or telling the user that the software found similar features on the part, and it indicated that with the 6x. So we have 6 identical holes. It's applied that feature control frame too. Now, the create position from datum rule can be edited from the model-based definition navigator here. Modifying the parameters will update all of our associated members, and we'll change the tolerance from 0.15 to 0.20. Now, the nice thing about this, you're going to see how quickly we can make that change across all of these different feature control frames on the part. Next, we're going to take a look at the PMI advisor in our design here. So in this example, we're going to use the PMI advisor and help us validate our PMI that was created on this part. So the PMI advisor can be found in our menu, PMI. First thing you want to do is go into the advisor here. And then we want to configure that advisor by going into the configuration option here. On the configuration dialog, you can customize your PMI advisor. And this main dialog is going to be for managing the types of rules that get applied to your PMI in the part. Over on the left-hand side here, you can see we can advise, enforce, or we can set that to off. So this is our checking mode we're talking about here. We can set that checking mode to have NX advise if there's an error with the PMI, or you can set it to enforce, which will also show the error and prevent you from adding the PMI that falls out of the compliance for that standard. So a couple of options here for your checking modes with the PMI advisor configuration. All right, getting into our next section here, our active standard. This is the standard that the part is being checked to when you run the advisor. There's your ASME and your ISO digital standards. You can choose the standard you want to use. In the middle section here, this is where you can select the different type of PMI or the different type of rule here, and you can set up and customize each one of those different rules. So feature control frames, invalid square zone shapes, all these different options here. In this case, feature control frame has no associated geometry. You can tell the software to flag that as an error here. If you wanted to apply the rule, you would check that box. If you wanted to not apply that rule and check for that rule, you can turn that off. But now we're going to set our failure level here to error, and that means if there's missing associated geometry to a PMI element inside the design there for your feature control frames, it's going to flag that as either an error, a warning, or you can have it show an informational icon on that item. Now getting into our datum feature symbol, we can go ahead and apply a letter here that's going to fall outside the compliance. So we're going to use the letter I here, and you can see on the alert it says a datum label must contain at least one alphabetic uppercase letter, and the letters I, O, Q, and X are not allowed. So it's flagging that with the red X over there in the alert box, but we're going to go ahead and apply the datum anyhow, and we can create that on the design here and place that inside the environment. After we place that, we are going to run our PMI advisor and have it check the PMI that's been applied to our part up to this point. So we can select the advise icon, and that's going to open up the PMI advisor here, and we can run the advisor check now on the part. This is going to interrogate the part. As you can see, we have a red X over there, and we also have some triangles with exclamation points. These indicate a warning. The green check mark indicates a pass, and we have a failed datum I over there with the red X. The PMI datum feature symbol A, that did pass the rule check. PMI feature control frame has warnings on it though, so you can read the information on the pop-ups. You can learn about why this has a warning on it, and you'll see if we put our cursor over the red X there, the PMI datum feature symbol failed the rules check. So now we're going to go back in and edit that datum feature to change the letter to B, which does fall within compliance here. So let's edit that. We'll change that from I to B. We'll close that out. Now we do have to rerun the advisor, so we'll run the advisor check one more time on the part. And once we do run that, that datum should now pass the check. We're within compliance now. We also want to fix our warnings on the position controls with our maximum material condition in the frames. So we can go into the rules and remove the maximum material condition modifier off of these feature control frames, and that will put us back in compliance with the standard. So we can jump back over to Model-Based Definition Navigator, select our Create Position from Datum, go down to the Details panel, and very easily hit the drop-down and set that to None. Now once that applies that change to all the feature control frames, we can go back into our PMI advisor, rerun the check, interrogate the part, and once we do run that check again, you're going to see everything is going to pass on our model, and we're now in full compliance. All right, so that is the automated PMI authoring and the PMI advisor demonstration there. Getting into our downstream uses for PMI, looking at the reuse of this information. Once you apply the PMI to your part, we can reuse this information downstream into a variety of different operations. In this case, analysis, inspection, and manufacturing are some of the use cases here with that PMI and model-based definition. So we can reuse that information. A colleague can take that model we've embedded the information on. They can perform some analysis, variational stack up. Maybe if they have a large assembly there and you have all that PMI embedded in all the components, we can use that with our VSA stack ups. Also, we can do some inspection programming here and generate our inspection programming paths on the part. Additionally, with manufacturing, we can have the software help us with generating the tool paths and also correctly picking the right tool that's going to be best for that feature on the part. So looking at tool design and analysis here, PMI-driven design and analysis related to the PMI and model-based definition process here. Once we reuse this information, it's going to be great for NX to leverage the PMI data for direct use inside variation analysis here. So we can simulate manufacturing and assembly process and predict the amounts and causes of the variation on the part. Also, variation analysis is going to reduce your analysis time by 50% and improve accuracy on that analysis as well. And mold concept design, 2D PMI symbols can be used to represent 3D standard parts and mold assembly with automatic placement here. We can utilize feature and tolerance definition directly from the PMI that's embedded on the part to quickly generate these VSA reports and do these variational analysis and stack up analyses on our designs. Machining, part planning, and NC manufacturing operations, we can use that PMI, and the NX CAM is going to automate your tool path creation and tool selection from the model-based definition information. It's going to select the correct machining process and tools depending on the machining feature, and is going to reduce NC programming time by up to 20% here. So another time savings. It supports the reuse of PMI in parallel product development process, and it leverages manufacturing knowledge within the machining process here. Line item on the bottom there, leverage knowledge captured about manufacturing requirements within the machining process here. And finally, with inspection processing, we can generate our inspection probing paths, and we can automate the inspection programming here. And that's going to leverage that PMI to automatically create inspection features, inspection tolerances, and inspection probe paths for your designs. This inspection method and feature types define the inspection path, and it's going to reduce inspection programming time by up to 80% here. So that's a huge time savings just by reusing the model-based definition on the model. This is going to ensure that CMM programming captures the design features and tolerances directly from the model without re-entry from a physical drawing. Getting into our final topic here, item 5. Take a look at a summary of benefits with the model-based definition. So looking at model-based definition and applying that PMI to your physical models, this is going to allow you to save time. It's going to enhance and shorten the design and decision cycles here with your products. It's going to deliver documentation electronically instead of on that physical hard copy prints. You can share that with your vendors, your customers, share it down with the machine shop if you need to. You can still create those drawings, those physical drawings if you need to do that. And I did show that earlier in the presentation by inheriting the PMI into a drawing view. But now the physical model is going to be the source of truth here. Also, this is going to save cost. It's going to reduce cost in drawing preparation time using the PMI-based models. It's also going to avoid or help to avoid those costly mistakes and by human error of picking an incorrect edge when applying a linear dimension on the part and those types of situations. Also, it's going to increase your quality here. You're going to reduce scrap and rework by analyzing, optimizing, and validating products virtually before cutting metal. It's going to increase the quality by optimizing the change management process as well. Let's take a look at some adoption strategies here. So if you want to start to implement the model-based definition inside your design workflow, for the adoption strategy, you want to develop a roadmap that aligns with your business goals. When producing an implementation plan here, include all the departments who could potentially leverage your model-based definition data as well. You want to plan and budget for education on working practices and technology for authors and consumers. There is a learning curve here. It's a relatively easy tool to get in and use, but there is still a learning curve. You want to plan and budget for that education so your users are familiar with the proper techniques of using the tools, not just application of the PMI, but also using the PMI advisor and implementing the model-based definition on your designs here. The process evolution, that middle section there, you want to establish the model as the source of truth here. You also want to develop working practices for both authors and consumers of your model-based definition data and consider how this data is going to flow between the different process steps, the different groups inside the company, and develop an online-offline collaboration process between those groups. For the risk management category, don't underestimate the cultural impact and ensure the benefits are clearly conveyed to all the team members here. You want to run your pilots with well understood use cases. Start with a simple product, simple project, something small. Run some tests internally with a smaller group, and then slowly roll that out to the other groups and make sure that you clearly convey the benefits of this process. This is going to help your company save a lot of time, money, and eliminate those costly errors with the manufacturing of your products. Also, you want to develop and track a productivity and return on investment here. Just like with any tool that you purchase for your company, any software, physical tools, you want to develop a track record, and you want to ensure the productivity is there with people knowing how to use the tool correctly, as well as look at the return on your investment and ensure that you have that return on your investment by teaching the users how to use this tool correctly. Also, anticipate investment in supplier adoption. With the embedded model-based definition on these parts, you can share these models with your customers and your vendors. You want to ensure that they're aware that you now have model-based definition on your parts, so they can do their part. If they have something that they're doing related to your product, they take your model, they have all the embedded information, the important information about that model, and they can reuse that information to speed up their part of the job and then get that model either manufactured or their process completed on that part, and then they can go ahead and pass that back to you, and you can finish off the production of the product. Licensing requirements for the model-based definition and PMI application on your parts. The capabilities, this is PMI authoring. The product name and price, the product name is PMI, and it is available for token licensing as well. I believe this takes 18 tokens to author the PMI on your parts. You do have to have PMI authoring capabilities on your licensing. So PMI can be applied to a part. If a user does not have access to a license with PMI authoring on it, they can still open up that part file. They can still interact with the PMI on there, and they can still interrogate that PMI information. They can create drawings and inherit the PMI from the model into a drawing view as well. But if you want to author this PMI on your parts, you do have to have the PMI licensing on your licensing setup. Prerequisites here: Mach 2 or higher license required to author the PMI on your NX parts. A Mach 1 and below can open, view the PMI on those NX parts, and you can also create drawing views and inherit the PMI from the existing model as well. All right, thank you for watching. There's my contact information. Again, if you have any questions, feel free to reach out after the presentation or the NX University session is completed. You can always follow up with me by sending me an email, and I will get back to you as soon as I can to answer any questions for you. In this presentation, we're going to be taking a look at NX CAD and some hidden gems and helpful tools and tips inside of your NX software. My name is Michael Pinto. I'm an application engineer and instructor here at Swoosh Technologies. Little background on myself. Over on the right, you can see I have over 24 years of experience designing products in aerospace and consumer goods industries for various companies, including Pratt & Whitney and Nike. I do enjoy teaching and supporting customers in their pursuit to achieve the best possible designs using the Siemens software products, and my areas of expertise are in 3D modeling, advanced surfacing, freeform modeling, model-based definition and PMI, assemblies, drafting, and stage modeling, as well as many other topics on the NX CAD side of the software. Getting into our agenda here, we'll take a look at some requirements validation, bookmarks, as well as roles to finish up the presentation. The first topic we'll look at here is requirements validation. We'll take a look at what is a requirement validation and how to create these requirements inside your NX parts. So covering the topic of what is a requirements validation, the user would like to have certain design checks for the part they're designing to verify quality controls, accuracy, and design features, and consistency of the design based on specific design requirements here. So you have your part you're designing, you have certain requirements that you want to meet with that design, and the solution here is that we can go ahead and apply or create these different requirements in various ways and have NX check the design based on specific criteria and flag the requirement as pass, fail, or give a warning to the user to inspect that particular part of the design and make adjustments if necessary here. The benefits of requirements validation on your parts. This is going to allow for error prevention. Requirements validation is going to help and identify those errors and potential issues inside your designs in the early portion of the design process here. This is going to allow you to correct those problems before they escalate, and it's going to reduce the likelihood of costly mistakes and rework in your design. Also, this is going to help with design compliance. By defining the specific validation criteria here on the design, we can ensure our CAD model is going to adhere to our industry standards, company guidelines, or specific project requirements for the design. This compliance is going to help us maintain consistency across the design and facilitate collaboration within our organization. It's also going to improve our design quality. So these requirements validation are going to help us maintain that high quality design, ensuring the models meet predefined criteria for the dimensions, tolerances, and other design aspects, and help us produce reliable and well-engineered products. Additionally, it's going to allow for time savings. Automating validation process can save significant time compared to manual checks. It's going to streamline the design review process, and it's also going to allow our engineer to focus more on creative and innovative aspects of the design. Getting into the types of design validation requirements, we have two different types here. One is called the ad hoc type of validation requirement. We also have a spreadsheet-driven type of requirement. With the ad hoc requirement, these can be created on the fly while creating associative measurements on your parts, and this is going to allow for easy creation of those requirements at the time that a new measurement is being taken on the design. An ad hoc requirement can also be created in the expression dialog. An existing expression or new expression can be used here to create these types of requirements. Looking at types of validation requirements continued here, we can also import requirements from an existing spreadsheet. So we can build a spreadsheet or use an existing spreadsheet either in native NX environment or from Teamcenter, and we can use that external spreadsheet and reference that inside of NX using the HD3D requirements tool, and we can import that spreadsheet and bring in all those requirements at one time. Note, Siemens does provide an example spreadsheet with requirements in it for reference by the user. This example spreadsheet is going to show proper formatting for defining new requirements and can be found in the following location on your client computer that NX is installed on. So you can find that in C, Programs, Siemens, the NX version that's installed, that folder, inside the Design_Tools folder, Requirements, and then the Examples folder. You will find the Siemens NX example file that is called requirement_spreadsheet_example XLSX. So this is a standard Excel type file. Now we'll take a look at a quick demo that goes over the process of creating these validation requirements on your parts. In this demonstration, we're going to take a look at creating requirements validation on our particular part here. So I have an ESCAM Explode assembly open in session here, And we're going to go ahead and take a measurement on the part. The way that these requirements are created on the part is that you can do that either ad hoc, or we can do that by prescribing some of these requirements to the part using some imported requirements as well. So the first technique we'll look at here is with the ad hoc method of creating a requirement on this part and then checking the validation on that to make sure it falls within the requirement guidelines. So I'm going to go up here and I'm going to create a measurement. So I'm going to go up to the analysis tool here, go into the measure tool, and I'm just going to take a measurement between two objects here. So I'm going to zoom up on the gasket part here, and then we're going to take a measurement from this ID of this hole on the gasket, and we'll take a measurement to this ID on the hole on our main gearbox part here. As you can see, we have a minimum distance being measured of 0.7500 millimeters. And when you're taking or going to save a requirement on this part, you want to make sure that you turn on the option here to save the measurement or create that associatively. So this very first icon over to the right after the measurement here, this is going to allow you to save this associatively once you're completed with the measure operation here. Additionally, over to the right of that, you'll see a couple of other icons, and then you'll also see a series of arrows pointing to the right. These arrows indicate that there's more information that can be seen here on this toolbar. We can click on those with the left mouse button. It's going to open up another drawer here and reveals two more icons. So with those additional icons, you'll see we have two more icons. If you put your cursor over those, it's going to bring up an arrow. If I click on that down arrow, it's going to open up another level and reveal a couple of operations here. So the second icon in from the far right hand side, you'll see we have an option to create none, which means there are no requirements being applied to this measurement. Existing requirement, which means we can go and use an existing requirement that might be already inside this part, or we can create a new requirement here on the fly while we're creating the measurement. So I'm going to choose the new requirement option, open up that ad hoc requirement dialog box, and now we can go ahead and prescribe some information here related to this requirement. So we can go ahead and give that a name. You can see we have a gasket hole edge to cam body hole edge description here. So you can type in whatever name you want there to describe this requirement. We can set the type under the dimensionality. You can see that's a length type measurement in millimeters. So the type of our requirement, we can hit the drop down and we have validation limit or design limit here. So we're going to set this as a validation limit. And then severity level, currently set to error, but if you hit the drop down, you can tell the software to flag this as an error, a warning, or a piece of information if this is outside of the prescribed requirements here. So we're going to go ahead and flag that as an error. So I'm going to choose error on that drop down section there. And down below, the data type is automatically recognized as a number, and that's because we've taken a dimensional measurement, a length measurement, and so the software automatically recognizes that as a number. So I'm not able to select that drop down and choose a different option there. For the definition method, we can create a single-sided comparison, a double-sided comparison. We can do a set of values, or we can create a formula here. Single-sided, obviously, just as it sounds, we can tell the software the expression is this, and that expression result has to be greater than or equal to this value in the input fields here. If it is outside of that requirement, in this case, it's going to be flagged as an error. So if that measured distance is greater or equal to 0.85, then it passes. If it's smaller than that value, then it's going to fail, and it's going to flag this as an error condition on that requirement. A double-sided comparison, if you toggle that on, you have two sides now to the equation. Here's your expressional value being measured, and you can have a requirement on this side and a requirement on this side of that value. We also have an option to create a set of values. So I can create a set of numbers here, 5, 10, 15, etc. And if this measured value, the result of that measurement, does not fall within the range or is not the same size as one of these valid values, it's going to be flagged as an error here. We can also create formulas here. You can also type in a brief description here of what that measurement or that requirement is doing on the part, and then you can select OK. So I'm going to set this back to a single-sided comparison. The expressional value has to be greater than or equal to 0.85 here with this requirement. I'll select OK. And as I complete that, creating the ad hoc requirement, you're going to notice right away that the thing that changed here on the measurement, you'll see that the minimum distance, the word's minimum distance, as well as the measured value here, has changed in color. So because we told the software to flag this validation or this requirement as an error if it's outside of the requirements here that are specified, it's going to flag that as an error. That color is going to be shown in red. So right away we're getting feedback on this dimension. We can see the lettering has gone from a black font to a red font, but that's okay. We'll just go ahead and finish the operation here. I'll select OK and complete creating the requirement there. Now, when you create these requirements on your parts, if we go over to the part navigator, you're going to see inside the part navigator here that there is a checks folder. Inside that checks folder, if we expand the plus node here, it's going to reveal our requirements that are placed on this particular part. Now we can see we do have a gasket hole edge cam to cam body hole edge minimum distance that's being measured there. It has the red X indicator on it, therefore it's telling me right away that this is outside of the requirements and it's failing that check. So it's flagging this as an error condition, and we can go in and investigate that if we need to. If you want to see the measurement that we just took, I can go back over to the part navigator, and there's a measure folder here. Inside the measure folder, we have a measure category. I can expand that, and you can see a couple of measurements that were just taken on the part earlier. If I click on the eyeball icon with the slash through it here and activate that, I can visibly see that measurement inside the graphics display on the part. So if we grab that measurement and move it up, visually we can see there is a red background, and that is because falling outside of the validation requirements that were specified on that measured distance here. If we want to fix that, we can either go in and we can increase the gap here by modifying the ID on the gasket here, and we can increase the value so it falls within the requirements here. So I'm going to jump back over and right click on this part. We can go ahead and make that the work part in session. Select my hole size here, and we can go ahead and open that up now. We'll go ahead and make that 7 here. Now, once we hit that enter key on the keyboard to update the diameter size of that hole, you can look in the graphics display and see that measurement at the assembly level has updated, and it's also removed the red background on that measurement. And that's because we are now falling within our requirements validation for this specific measurement. Now, if I go back up to the top level of the assembly, go back to the assembly navigator here, right click on the top level part, make that the work part, you can still see that our dimension is updated. And if we look at the part navigator now and you look in the checks category here, we have those green check marks representing the condition where this is passing that requirements check on the part for that distance. If you need to edit these, all you have to do is either right click and go to requirements validation here. What that's going to do is that's going to open up the HD 3Ds tool panel here. The HD 3D tools panel over on the resource bar is icon you can see on this tab here. So you can click on that to get to the HD 3D tools panel, or you can edit one of those validation requirements, and it's going to open up that panel for the user here. These HD 3D tools inside this tool set, these are on-off functionalities here. So you'll see up in the top left corner, we have an option to deactivate this tool. If I turn that off, you can see it removed the check indicator on the actual measurement here in the graphics display, but it also turned off the panel in that HD 3D tools. So there's the requirements validation, and we can go into the requirements validation, reactivate that by double left mouse button clicking on that to open up the panel. That is now active in session here. We can see there's the power button. If you need to deactivate that, you can click on that again to deactivate that. Inside the HD 3D tools panel here, you can see there is our gasket hole edge to cam body hole measurement here. And there's the minimum distance requirement that we created there. If you put your cursor over that requirement, You'll see the green check mark, of course, because now we're within the guidelines for that validation of that requirement. And you can see the check status is passed. The requirement formula is the expression value, has to be greater than or equal to 0.85. The check value is in millimeters, and then the check expression is P1. Measure various 33 is the feature there. If you want to edit this, you can right click on this, and we could go down to edit requirement here. All right, with the edit requirement, you can see it's opening up the ad hoc requirement dialog again. We can customize the name there, change our validation type, change our severity level, the data type, and we can also change our definition method for this ad hoc requirement, as well as the value over here. I'll select OK to finish that out. Additionally, we can show the view style using different methods here. So right now we're looking at the flow list plus tree. So we have this flow list of those requirements, and we have the tree in the table down below here. If we set this to just the tree, it's going to just show us that table down below and the tree structure with those requirements. Over in the graphics display, you can also see the indicator over the measurement with the requirement applied to it, and we do see the green check mark as well. If you put your cursor over that, you'll get the pop-up information window here, also showing you that this has passed the check, the requirement formula, check value, as well as this check expression here. If you want to show other information, down in the settings here, we can show the passed items. If I uncheck that, you're going to see it removes that indicator off of the part. We also can show the pass with information, pass with warning, show the failed items. So these indicators will show up in the graphics display for the user there. Also, up in the table, you'll notice when I turn off the show passed, it removes requirement validation up there from the table, and now it's no longer going to show up there. If I turn that back on, it shows the passing requirements here. We can also go out to fetch requirements if we need to do that. If I click on the icon over to the right of fetch requirements, that's going to open up the fetch requirements panel. The source type can be prescribed here. In this case, we have a spreadsheet or XML file and native file system, but you can also access a source type from Team Center. And then if you have your requirements built into Team Center, you can go out and access those requirements and import those into the part file here and run those requirement checks on your part. But because I have a native environment here right now, I can just choose spreadsheet or XML file and native file system. The source, I can go ahead and click on the browse for spreadsheet or XML file, and you can see my requirement spreadsheet examples right there. So I'm going to go ahead and open this up, and I can select the sheet that I want to import that has the requirements on that sheet inside the spreadsheet. So I can hit the drop down, choose NX check requirements. As soon as I do that, we can see right away we have a lot more requirements that have been populated in the table over here inside the HD3D requirements validation panel. Also, out in the graphics display, you'll notice that we have a couple of indicators that showed up here as well. So as soon as you import these additional requirements into the session inside this active part, it's going to begin checking or running those requirements on the part. So if we look at these additional requirements, I can see there's a height requirement here, overall requirement validation status unvalidated, requirement formula expression is greater than 80 millimeters. Different requirements are automatically being applied to my part based on the imported requirements here. Now, if you need to edit these, you can always go back into the spreadsheet and edit those. And once you edit the spreadsheet and save that spreadsheet, it's going to update your requirements that are being imported here. You do have to refresh the requirements from the external source by using this button here. Once you do that, it's going to update those requirements, and it will apply those validation checks or requirements on the part after being re-imported into the session here. And Siemens does provide an example spreadsheet that you can use. I'm going to go ahead and open that up just to show that, and we can take a look and see what that spreadsheet looks like. So just give me one moment here, and I will open up that validation requirements spreadsheet that we imported into our session here. All right, and once that spreadsheet launches here, you can see the name of this is Requirement Spreadsheet Example XLSX. This is located in the install directory of your software. If you have a native installation of the software, that is located in the program Siemens NX, whether it's NX12, NX2306, or future versions. You want to pick that directory and then pick the design_tools directory, requirements, examples, and then the Siemens NX example file name. Now inside of this spreadsheet that Siemens does provide as an example, you can see over here we have our name of the requirement, a text and overall description of what that requirement is doing. Also, you have categories here, and these different categories, if you look at the way the spreadsheet is built, you're going to have some nice descriptive information. All you have to do is move your cursor up to the header here, and inside that header you are going to see a description pop up that tells you about that particular column, what the information of that column is going to do for your requirement. So that is the provided out-of-the-box requirement spreadsheet example XLSX file here. You can customize that, and you can put in your own requirements here or edit the existing requirements inside the spreadsheet. I'll go ahead and close that now. If you do update the spreadsheet that pulled these requirements in, remember to refresh the requirement from the external source here by hitting this button here. You'll see a quick flash of the requirements icons on the screen, and those requirements have now been updated by any external changes to that spreadsheet. So that's going to wrap up our creating validation requirements demo. Hopefully you found that useful. And if you have not seen these before, hopefully you can start to incorporate these different types of requirements checks on your parts inside of your NX software here. The next hidden gem we'll look at in NX CAD is going to be bookmarks. So we'll take a look at what is a bookmark and how to create a bookmark inside your NX parts. So what is a bookmark? We can use these bookmarks when we want to retrieve information about current states of our model, and bookmarks can capture data for the following items: currently defined session component groups, assembly load options, assembly structure, as well as many different display settings inside that environment. So these bookmarks can save time and allow you to jump right back into work on your complex parts or assembly in the state that it was in when the bookmark was actually saved. A bookmark file can be shared with your colleagues, and we can allow them to open an assembly in the exact state that it was in when that bookmark file was created. So if I'm working on a project and I have that certain components hidden in the display, I have that zoomed up on in a sublevel assembly I'm currently working on, and I want to share that with a colleague, I can save a bookmark, send that bookmark file off to the colleague. They can open up that bookmark file. NX session will open up. It's going to load all of the components as they were saved. That is the components that were currently displayed on the screen, the level of zoom on those components, as well as any graphical display of those components will be retrieved from the bookmark and will open up on that user session, and they'll be in the exact same position that I was viewing the assembly when I saved that bookmark. All right, how do we create these bookmarks? We can use Save Bookmark from the menu option here. Bookmarks can easily be created and shared by going to File, Save, and Save Bookmark. So once you zoom up on your assembly or you have that component or that assembly positioned inside the graphics display, just as you want that be saved inside the bookmark, you're going to go up to File, Save, and then Save Bookmark there. So bookmark files are going to be saved as a PLM XML file format here. That is the extension you'll see when you do save these bookmark type files. These are a lightweight file, so you can easily save these in an email, send that off to a colleague inside of an email. They can open up that email, double click on the PLM XML file, and that'll launch their NX session on their computer, and then open up that assembly, load that assembly with the correct load options, and have that in the exact appearance that you saved the bookmark in. We can also use the HD3D toolset and the bookmark tool functionality there. So on the left-hand side, your resource bar, you can navigate down to that eye indicator, click on that icon, and in the HD3D tools, you can navigate down in that panel to the bookmarks option. You can double click that to open up or activate the bookmarks panel. And now we can go ahead and create a new bookmark by selecting the Create New Bookmark icon in the bottom right, as you see there in the image over on the right. In the bookmarks panel, you'll also see previously saved bookmarks, so you'll see those up above in that panel as well. Now we can set our default bookmark directory here. This is the directory where your bookmarks should be saved at by default when you do invoke these save operations for bookmarks. That default bookmark directory, that's going to be set inside your customer defaults. So if you want to get into the customer defaults, you choose File, Utilities, Customer Defaults. In the Customer Defaults dialog box, we can select Gateway, General. We can click on the Directories tab, And then under that bookmark directory in the appropriate box for your operating system, type the path for the folder to which automatic bookmarks are going to be saved, and the context of those bookmarks will be saved in that directory. Once you're done with that, you can select OK. And remember, when you edit these customer defaults, you want to restart your NX session, and then these settings you change in your customer defaults will then take effect. Note here, if the specified folder does become invalid, bookmarks are going to be saved and defined inside the temp folder. All right, now we'll take a quick look at creating some bookmarks inside of our NX parts. So in this demonstration, we're going to take a look at creating some bookmarks inside of this race car assembly. So the way the bookmarks work, all we have to do is set up the view that we want. And so I'll zoom up on this rear tire inside my race car assembly. And if I want to create a bookmark of this presentation, so I can quickly get back to this view zoomed up at the level that it's at with the correct components loaded here, I can very easily save a bookmark to get back to this condition later on, or send this saved bookmark out to a colleague and they can open up that bookmark. That way it'll launch their NX session, it'll load up the race car assembly. It's also going to load all the assembly components based on how they were loaded when the bookmark file was saved, and zoom up to this rear tire on the race car assembly here. So to save the bookmark, let's go back up to File, Save, and then you'll see over on the right-hand panel here the Save Bookmark option. Click on the Save Bookmark option, and now we can go ahead and save that. In this case, we're saving that out in our temp directory here. So we'll save that inside this temp directory. I'll just call this rear rear tire view race car assembly, and we'll go ahead and save our PLM XML bookmark file type here. So there's that extension .plm XML. We'll save that in our temp directory here, NX bookmarks, and then we'll select OK. Now that we've saved that bookmark, we can easily get back to that bookmark or that condition by reactivating that bookmark or sending that off to another colleague. They can open up that bookmark. It's going to launch their NX session, load the race car assembly up in this condition, and it's going to be in this exact orientation when they open up that bookmark or that assembly. If you want to open up a bookmark, you can go to File, you can go to Open here, and then you can go back out to your bookmark directory. And now inside that bookmark directory, when you get inside this directory, make sure that you pay attention to the file type here. Right now it's set to part files. If I open that up, and we set that to the PLM XML bookmarks file type, you'll see inside that NX bookmark directory, my temp directory here, where my bookmark was last saved, you can find that rear tire view race car assembly PLM XML file. I can open that up, and that's going to open up the assembly in session and position that exactly as it was when the bookmark was saved. So if I rotate this, we'll just go ahead and demonstrate that really quickly here. So if we're looking at the assembly, maybe I have a couple of these components hidden here, and we're focusing on this portion right now. But if I want to open up the bookmark, I can go right back to File, Open, go to my directory of my bookmarks was saved, click on the bookmark, select OK, and bam, we're right back in the same situation or same appearance of that assembly and the same orientation with all the components loaded and visible as the bookmark was saved here. You can also go over to the eye indicator here, which is your HD 3D tool panel. And I'm going to turn off the bookmarks toolbar or functionality here. So I'm going to turn that off. And inside of the HD 3D tools panel here, if you scroll down to the bottom, you are going to see there's a bookmarks option here. So we're going to go ahead and double click on that, open that up. And inside of that bookmarks panel, we have a filter here, and we can display the bookmarks for the displayed part, which is the main car assembly here. Or we can display the bookmarks and all of the active parts that are open inside this NX session. So you can see I do have my cam part over here, my cam assembly, and I have related bookmarks to that cam assembly as well. The main car assembly, if I click on that, it goes back over to that as the active work part in session, and you can see there's a bookmark related to that one down below here. If you only want to show the bookmarks related to the currently visible part inside the graphics display here, set this to displayed part, And now it's going to narrow down the bookmarks that are saved for this particular file. So I can always click on that bookmark, get back to that condition. So I'll go ahead and rotate this, click on the bookmark, and it's going to go right back to showing me that representation and that orientation that the bookmark was saved in. You can save as many bookmarks as you need to here. And we can also create a new bookmark from this panel here by selecting on the new bookmark icon here. So what I'm going to do here is I'm going to rotate to the front of the car here, right click, I'm going to hide the tire, hide the wheel, and we'll zoom up on the brake assembly here. And we'll save a bookmark right now. So we'll go to the new bookmark option, click on new bookmark, and we can give that a name. So I'll go ahead and main car assembly 1, front brake assembly. You can type in a description here, and you can also tell the software exactly what to capture when you save that bookmark. The assembly context, component groups, options and structure, component groups and load options, or component groups only here. And then you can also maintain the display settings. That is the visual representation of the parts here, and this is in a fully shaded with wireframe or edges being displayed here. So it's going to save that inside the bookmark. So I'll select OK. And now we've just created a new bookmark that shows up in our HD 3D Tools bookmarks panel here. We can easily access any one of these bookmarks and get back to that condition. Some nice benefits here is that if I go off to a design review, if I save a bunch of these bookmarks, I can easily navigate through my assembly when I want to talk about the brake assembly or the rear tire. I can go ahead and double click on that bookmark and go right to that condition, and we can talk about that rear tire inside my race car assembly during the meeting. If I need to jump over to the brake assembly, I can double click on that bookmark, and now I'm looking at the brake assembly and I can begin discussing that with my team members here. All right, so that is creating bookmarks inside of your NX files. You can do that with assemblies, or you can do that with single components if you'd like to do that. Also, one more item here. If I do go back over to the history icon here, over on the resource bar, you'll see that bookmarks will show up inside the history here. You can also pin these bookmarks by clicking on or hovering over the bookmark and going up to the far right corner, and you can go ahead and click on the little pin button here, and we'll do the same here. I can go back to this one, I can pin that bookmark, and up above you're going to see there is a pinned folder. So I can click on the pinned folder, and these are all the different bookmarks that I pinned open, and I can quickly click on that, and it's going to open up that assembly and go to that orientation as it was saved for that bookmark. Here's the cam assembly again with a different bookmark. And now we can go back over to the race car and look at this bookmark where we saved the brake assembly and go right back to that if we need to do that. All right, so that is bookmarks inside of your NX software. Hopefully you found some great benefits with that and you'll be able to use this in some of your future designs. The next hidden gem in CAD we're going to look at here is item number 3, roles. So we'll take a look at what is a role and creating roles inside the software. So the first item, what is a role? So roles are going to help you customize your user interface to match your job functions. We can save a role and user interface settings under an assigned role, and we can also use those user settings to include the following items. We can customize tabs, groups, and galleries. We can also customize the location of tabs, groups, and galleries, and commands on the ribbon bar. So anything that you can customize on those toolbars, those ribbon bars, and your menus, etc., we can save those into a role and always get back to that same setup of all those items on your toolbars, your menus, as you've customized those. So by creating roles, you can create as many of those roles as you need to, and you can share these roles with other users as well after they're created. Getting into creating roles, to create a new role, after you customize your ribbon bar, icons, etc. inside your NX interface, these customizations can be saved as a role. You can go down to the resource bar on the left-hand side, go down to the folder that's got the hammer and the wrench, and go ahead and click on that and open up your roles panel. You can right-click on the context menu and choose the new user role option. And once you choose the new user role option, it's going to open up that roles properties dialog, and you can go ahead and customize the name of that role. You can choose a bitmap to place as an image for the role, and it does have to be a bitmap type image for that image. You can also type in a description there, and you can also type in the role type down below, and you can designate the applications that this role takes effect in. You can also save your dialog memory as well, and when you do open up different dialogues, set different settings in some of those feature dialogues, you can also have all those settings be saved with this role here as well. Once you're ready to save that, select OK, and it's going to create the new role inside your roles panel there. All right, getting into a quick demonstration of creating roles inside your NX software here. All right, in this demo, we'll take a look at creating some roles inside of our NX environment here. So going up to the toolbar, if we want to customize the toolbar, I'm just going to go over to the Home tab, and I'm going to add an icon to my toolbar up here on the ribbon bar. So I can do that by right-clicking and going to Customize here. And I'm just going to search for the measure tool. So I'm going to, inside the search panel here, I'm going to type in the word measure. And there's my measure tool. I'm going to left mouse button down, hold my left mouse button down and drag that up to the toolbar and place that on the toolbar there. All right, now that I've customized my Home tab with the measure tool on that, and I want to save this role, I can go over to the far left-hand side, go to the resource bar options, scroll down, and go down to the roles folder here. Inside the roles folder panel, you're going to see I do have some existing roles that I created earlier, but I can create a brand new one by right-clicking and choosing the new user role option here on the context menu. Once that pops up, I can type in my name. I'll just call this Michael Custom 2. I can choose a bitmap image if I want to. It does have to be a bitmap image here, so you can browse out, find a bitmap image to apply to that role, and it's going to show up just like you see my image over here in these other roles I've created previously. Give that a description. I can specify if I want it to show up in the content, presentation, or content and presentation type folders here. Also, I can set the applications inside where I want this role to take effect in, or what applications I want this to save the toolbars for with this role. I can save the dialog memory, and then I can select OK here to complete creating that role. Now, if we look over in the roles panel, there's my Michael custom role. If I were to switch to one of these other roles, like the advanced role, you can see the toolbars have all flashed. I've lost the measure tool on that Home tab, but if I do want to get back to that same role again, or that condition, I can go into the user folder here and then click on Michael Custom 2. My toolbars update, and I once again have my setup here for all my custom toolbars, and my measure tool is again on my Home tab here on the ribbon bar. If you want to save these roles or you want to share these with another user, you can easily do that. These roles are saved on your local directory on your computer, and I can show where that's located at here. By default, the default location, I'll go ahead and navigate to that location here and show you where that's at. So I'm going to go over to my C drive and bring that over. So on that C drive, you're going to go into the users folder, go into your username, and then get into the application data folder. If you don't see the application data folder inside this, your username folder here, you need to turn on the application data or turn on the visibility of the application data folder here. So you can do that by going up to the ellipsis button here. This is Windows 11, by the way. It might be a little bit different in Windows 10, but you want to go down to the options for your Explorer options, open that up, and on the View tab here, you should see a Hidden Files and Folders option in the Advanced Settings. You want to show hidden files, folders, and drives here. Once you toggle that radio button, select OK, you should see this application data folder. Double click on the application data folder, go into the local folder, scroll down here until you find the Siemens folder. And inside the Siemens folder, you're going to see all the versions of NX installed on your computer. So I'm going to go to my NX 2306 folder here, open that up, and inside of that folder, you're going to see there is a roles folder here. With the roles folder, you're going to see all the roles that you've saved for your NX 2306 software. So these will be saved in here. You can always right-click on these, copy these, and paste these in a standard directory or a shared directory for other colleagues to access that. You can copy this. It's a lightweight file, 269 kilobits here. So you can easily attach that to an email and send that off to a colleague. And then they can load that role and use that role on their setup there. Now you'll notice the NX role name here is not the same name that you saw over in the software. So if we move this aside, you can see Michael's Custom 2 role, and you can see today's date right there for that role. It has a different name inside the Explorer here. This is the name that the software recognizes when it loads this role or uses this role inside the software. This is the name or the username that helps me to know descriptively what this role is that I saved here. If you want to ever find out what the software role name is, you can right click on that and go to edit here. And if you look up at the top, it says nx_role2.mtx. That's the name that the software recognizes. I could always right click on this, copy that name right there, and then go back over here and then rename the role inside this folder to Michael Custom 2. That way it's easier for me to recognize what this role is here when I share that with another user or put that in a share drive that other colleagues can access there. So quick little tip there. Now, if you do want to load a role from another user, you can go to File, go to Preferences, go into User Interface here, and then you're going to see on the left-hand panel, there's a role category here. You can click on Load Role right there, go out and find the role, load that in session, and then select OK or Apply here to load that into your environment here. Once you load that role, make sure you right-click and create a new user role here and give that a name to save the loaded role that you just loaded over here in the panel so you can access that later on. All right, so that's how you can create these custom roles inside of your NX environment, reuse those, share those with your colleagues, and standardize the toolbars if you need to do that for different types of jobs or different roles for your users inside the NX software. So that's going to conclude the demo. Hopefully you found some good benefits here with the ability to create these custom roles and share those with other users. And that's going to conclude our NX Hidden CAD gems here for today. If you guys have any questions related to any of these topics, feel free to reach out to me and I'll help you out with any of those questions. Thanks for watching.
Hello, everybody. Thanks for joining me for this presentation. In this session, we're going to be talking about NX Routing Electrical. It's one of the applications that you'll find in the NX CAD applications. And in this presentation, we're going to be doing mostly an introductory level presentation for some of you who may not be acquainted with NX routing. So let me introduce myself first. My name is David Chu. I may have met you. I do work with a lot of our customers. My background is in NX CAD and also in Team Center. So for Swoosh, my current role is Customer Success Manager, but I've been involved as an NX instructor. I also know quite a bit about Team Center, so I've been involved in Team Center projects. And in this particular session, I'm going to be going through a demonstration of kind of an end-to-end day-in-the-life sort of a process using NX electrical routing. So as you see here on the slide, I've got my contact information, so feel free to reach out to me if you have any questions or if there's anything that you think I can help with. My LinkedIn profile's there as well. So welcome to get connected with any of you out there. So I've got a pretty simple agenda here for our session today. I'm going to just start off with a few minutes just to introduce some of the concepts behind NX Routing Electrical, and I'll spend the vast majority of my time doing a demo for you. So let's go ahead and get started here. You might have heard us talk about this concept of digital twin, trying to get as complete a representation of your product as possible. So routing plays a big part of that, of course. When you're talking about either a mechanical or electrical routed system, you want to be able to make sure that your design is as accurately represented in your model as possible, so it plays along with everything else that you have in your product design, as well as with some of the logical design that might go into the definition of the product. You've got your systems engineering that is usually done up front before you do the physical design of whatever routed system that you have. So this is kind of the end point of that process. We'd be picking up from a system design and putting together the physical representation of that design in our NX model. So one of the things that you're going to see here is that there might be some commonality that you'll notice between different routing modules in NX. So there's two primary modules that you'll see: electrical and mechanical. We're going to focus mainly on the electrical side of things today. And within those two areas, there's some disciplines that can further refine how we use the application. So on the electrical side, we have wire harnesses, we have cableways. For example, on the mechanical side, you've got piping and tubing, HVAC platforms. So each of those have unique design requirements. So you'll see different libraries used. You'll see the application of different design rules. So behind the scenes, I'll try to point this out as I go in the demo. There's some design rule checking that happens. So there is some common functionality. The path creation is going to be similar between the two, and I'll try to point out some differences between electrical paths and mechanical paths. There's a combination of tools that you might want to use. And you can also work with parts that you can place within the routing application, but you can also stick with your standard assemblies if you like. It's pretty flexible. So in that regard, let's talk a little bit about part placement. So that's going to be one of the first steps that you go through when you're designing your routed system. So for electrical parts, you'll have connectors, you might have devices, you might have some clamps that hold wiring harnesses down. So again, you can place those parts either using your standard assemblies tools or using the part placement tool within the routing package, which I'll show you. So one of the things that you'll notice is that the parts will have these arrows coming off of them. Those represent connection points, and we call those ports in NX routing. So we have a process that we call qualification. So qualifying parts is what we do to add these connection points, these ports, so that you have parts that come together. So maybe two connectors might fit together, or you have wires going into a terminal or into a connector in specific ways. So those ports help to define those. They also help to define orientation, so you can have clocking of parts relative to each other. So I'll try to give you an example of that when we get into the demo. So a big part of the routing systems is being able to reuse qualified parts, approved parts, especially for your designs. So if you want to have uniformity in your application of parts in your designs, you'll probably want to use the reuse library to manage your parts that you'll bring into your assemblies. So not only can you just have a repository of parts, but you can also set up different characteristics that you can search through your library. As you can see here in this example, it's a mechanical example here. So you can search for things in your library based on size, on classification, various parameters that you might want to use to help locate candidate parts in your library that you might want to use in your routing system. So a lot of the work that we will do, and a big part of the demo, is routing the paths through an assembly. So that's going to represent, of course, the area within the assembly where either your tubes or your wire is going to pass through and among all the different components in your assembly and connect to various components in your system. So we'll be able to use different kinds of paths. I'm going to use primarily spline type paths for wiring, for mechanical routing, may be more appropriate to use linear paths. So I'll at least point that out to you when I get into the demo and show you where all these tools are. So something that happens behind the scenes is design validation checking. So rules are applied as you are creating and editing your routes within the software. It'll give you real-time checking. So anytime you are working with a path, for example, or you're moving parts around, you can check the status line, and you'll see that there'll be some checking. I'll point that out as I go through the demo. If there is a violation that occurs, the message will come up right away, so you'll know. You don't necessarily have to fix it. It's not going to stop you dead in your tracks. So you can continue to do your task at hand, and then come back and fix those. So there's the ability to rerun checks a little bit later. I'll show you where that is in the toolbars. So let's go ahead and get into the demo. Here's the outline of what we'll do. Like I said, it's going to be kind of a day in the life sort of presentation here. So we'll start off from the beginning by setting up a part to be able to be used in a routing assembly. So that's called the qualified part command. Then we'll place parts in an assembly to show you how that's done. If you've worked with assemblies before, it's no big deal. But then we'll get into the routing specific tasks, creating paths between components, and then defining the actual routed system design, so to speak, the component list and the connection list. In our case, it's going to be electrical routing that we're going to be doing. So we're going to import some information that may come from the schematics package, for example. So then we'll route the wires. We'll get some actual stock applied to the paths that represent wires that go from component to component, and then lay the wire harness out flat into a 3D, I should say 2D representation of the form board of the harness. So going all the way back to our assembly, we can go ahead and make some changes to our design and update the harness, and then also update the form boards to show everything is associative. So let's go ahead and get into that. So let me change screens here. I'm going to go back to my NX. And let's go ahead and take a look at what some of these tasks might involve. So the first thing I'm going to do is open up a part that I might want to use in a routing assembly. So here we have a connector. Let me rotate this around so you can see. So it's a pretty simple model here. And if you take a look at the part navigator, you notice it does not have to be a native NX part. It's going to be quite common that you might get parts from different suppliers, and you might get step model maybe that represents the part. So it's not required to be a native NX part, but we are going to go through the process of just adding some intelligence to this model for routing purposes. So let me go ahead and go up to the application toolbar. Let's go into our routing electrical package. And we're going to go ahead and do a qualification of this part. So you'll see in this toolbar, let me just kind of point out what we've got to deal with here, going from left to right, up in the top. So we're in the Home tab of the routing electrical application. First group of commands here are the path commands. And we'll be working with mainly the spline path here for electrical routing. Then we get over here to the next group of commands. This was where we can apply different kinds of stock, to our paths for the size of, let's say, a wire or the size of a tube. You can, as you can see here, you can also apply overstock, which might be a wrapping over a wire or insulation, for example. Then the next group of commands deal with parts, manipulating parts. I'm going to be qualifying parts here. And then we got some other utilities that I'll get into a little bit later on. So let's kind of jump into this. And let's go ahead and qualify this part. So if you take a look at this part, there's a couple different ways that this part might connect in a routing. You can see it's got a clip here. So this is a connector. It might attach to another, attaching component. So that might happen here on the clip side, on the opposite side, and we might have some wires coming in here. So I'm actually going to define two different ports here And that's the objective to qualifying parts. So we want to assign some ports. So I'm going to call this a fitting. So a fitting is a device or a connector in the routing. So this is going to be connector slot clearly. And let's go ahead and define a port. So a single port is what we might call a fitting. Like I said, this is a common command that's used between mechanical and electrical. So we're going to call this a fitting. And for a single port for a fitting, like for example, the side on the right where another connector may attach to this, let's go ahead and select. I'm going to use midpoint on face, if you see here, and just select this face on the end, and you'll see a port sticking out there. This is going to be where another connector might be able to attach to this one here. So I'm going to go ahead and also specify a rotation vector. See, that's optional. The rotation vector is going to let me add the part, place it into an assembly, and maybe clock it different ways very easily depending on what angle I want to choose. So it might go in, like for example, it might go in 90 degrees from where I might want it to be, and I can always clock it 90 degrees to very quickly place it. So I'm going to go ahead and specify a rotation vector. And let's specify a face here, and I get this little upward vector that you see there. And based on that vector, I might want to allow for, maybe different 90-degree rotations of the part to get it into the right position when I add it to my assembly. So let me go ahead and add that. Okay, so that's the first port. You see it there. That's where those arrows come from if you see any kind of qualified parts in an assembly. So that's just a simple port. On the opposite side, we've got 3 different wires that might come in here, different terminals. So I'm going to do a multi-port on this side so you can see what terminals look like. So let me go ahead and create a new port on the opposite side. So I'm going to do the same thing to start with here. So I'm going to go ahead and select the end face here and have the port defined there at the midpoint. The double arrows is for the multi-port versus a single port on the back over here. I am not going to specify a rotation vector in this place because this is where wires are coming in. It's not really going to play a role in how this part is placed in the assembly. So I'm going to go ahead and click OK for now. So I've got my port sticking out there. I have not defined terminals yet. That's something that we'll do here in the next step. So we'll right-click there and we'll assign terminals. So when you define terminals, you can do these manually one at a time and just specify a location we want a terminal defined where a wire might come into this part. We can also do it very quickly. This is a simple example. I've got just 3 locations. I can generate multiple terminals at once, either numerically or you can see here alphabetically. Let me just go ahead and use alphabets here and go from terminal A to terminal C. And let's just generate all those at once. So these will get added to the list up above. And then, these are virtual parts. They're not yet represented on the geometry. So we still need to go in here, select, like, let's say, terminal A. And if terminal A is supposed to be the one here on the left, I need to specify a point over there. So I'm going to go up here to the point dialog. And let's use between 2 points. And I'll specify a midpoint right there and a midpoint over here. So I get that point in the middle. And then I want to specify what direction the wire is going to come into this terminal. So I need to specify that vector. I'm just going to go ahead and specify the face on the end there. You see the arrow coming out. And I need to do that for the other 2 terminals. So you see in the list there, it says that port's been placed. So let me go over here to the next one, and I'll just go through the same process. So bear with me while I change my point dialog here and specify a couple points, get that point in the middle, and then specify the vector sticking out again. So let me do that one more time for terminal C. Over here. Oops. Forgot to change my, there we go. There we go. I got my point there in the middle. Again, specify that same outward facing vector. So if I rotate my view where you can actually see them, you'll see I got my 3 terminals sticking out. So later on when we route wires, it's your option to see up here in the ribbon bar, there's an option to create terminals. So when the wire comes into this connector, it's your option if you want to actually model the terminals that show each wire coming into this connector. You can do that if you like. Again, it's optional. Let me click OK, and we're done. That's what the qualify process involves. Pretty much defining the attachment points for your part and defining where wires might come in. One thing that's easy to forget is you do want to add these ports to your reference set for this part so that you can see the ports when you add the part to your assembly. It's a really easy thing to forget. And then when you add your part to the assembly, you'll be wondering why you can't see these arrows and you can't select them. So don't forget, I'm going to go ahead and do that just to reinforce the notion here. You can either create your own reference set or use the model reference set. A lot of people like to create a new reference set. So I'm going to go ahead and do that. I'm just going to call it route or routing. You can call it whatever you want. It's kind of up to you. And then make sure you select the model along with the ports and terminals. Then you'll be able to see that in the assembly. So we're done with that. I'm not going to get into setting up the reuse library today. There's just not enough time to do that. But I do want to go ahead and move into the next portion of the demo, which is going to be doing a complete harness design. So let me switch over here. I want to go ahead and open up an assembly I want to work with. All right, so we have this electronics box here, and there's some components on the inside that you can't see yet that I want to work with. So let me hide the cover. So here's our parts. And you'll see several parts have already been placed already. If you've got a good eye there, I'll just go ahead and zoom in, make it a little easier. There's some components here that you'll see that have the ports on them already. And that's what I was talking about before. So just make sure your ports are available in your reference set that you want to add, include when you add your parts to your assembly. And I'll show you an example here in just a minute. Let me go to my harness assembly. So just like any other assemblies task, just make sure you're working in the right work part when you're adding parts to your assembly or if you're routing wires, things like that. So make sure you're working in the right part, of course. And let's go over here to electrical routing. I also want to show you the disciplines. So over here under the toolbox, if you're working in a specific discipline, you'll see how you've got different ones here. Your choice of discipline is going to affect the parts that you'll see if you were to draw any parts from your reuse library. And it's also going to affect some of the design rules that are going to be applied as we work. So I'm going to be working in the harness discipline. So just make sure that's turned on. You'll find out if you forget to turn that on, if you go to try to choose stock out of the reuse library, you might not find anything. So make sure you've got your proper discipline checked here under the toolbox. All right, so let's go ahead and place a part. I want to show how that works. So we've got 90% of my parts are already here. Let me throw in another part just to show the process. If you want to do it with assemblies, that's fine. I'm not even going to show that because you're probably all familiar with that already. But routing electrical does include its own command for placing parts. It's right here, this orange icon. So you'll see it starts off a lot like assemblies. We can go to a reuse library. I'm not going to go into the reuse library. Again, there's not enough time to get into all of that, but I'm just going to go ahead and add another part that I've already got in my assembly. So I've got this little terminal. Let me go ahead and select that part. And let's see what this looks like. So when you place the part, this is one of the benefits of using these ports. So if I choose a port, like I've got this little block up here where I want to put this terminal, if I choose that port, it's going to align the ports. So you see how it aligns the ports. And then I can choose, if there's a couple sets, there's 2 ports on this particular part, and I can cycle through those. So I can say, okay, do I want that port? No, that's not the right one. Cycle to the other one. Now that's the right port. It's not exactly in the right place. So you can either click and drag the handle, or you can go down into the dialog here and just say, or up here in this banner, right hand rule. So that's going to be a -90, and make that terminal point downwards. And that's it. So that's how the ports are used for placement. NX routing will align the ports and give you rotation around those ports, so you can clock the part the way that you want. So that's part placement in a nutshell. I need to move on here in the time that we've got. Let's spend some time looking at path creation. We're going to spend some time here with some of the commands up in the left part of the ribbon bar. So the idea of creating paths, I'm going to connect all the components in my harness. Most of them are placed right now, and to get associativity to the parts, if they were to move around in your design, it's best to select the ports coming off of these parts. So since this is a electrical design, I'm going to try to simulate the wire shape using a spline path. And for spline path, all I need to do is pick the points where I want my path to go. So I'm going to go from right to left. You do have to pick them in order, of course. So I'm going to pick the first port over here on this yellow connector. Let's grab that one. And you'll see a couple arrows. One arrow represents an extension length, which is how far out of the connector the wire has to come out before it can change direction. And then there's a direction arrow. So if the port's pointing the wrong way, for example, I can flip that arrow. So I'll play around with that a little bit here when you see more geometry on the screen. So I've got that. From that connector, we're going to pass through this clamp. So let me select this port as my next. So here's what you see there. So if I go back here and click and drag this extension, you can see the effect of that. So there's an extension coming off of connectors. There's front and back extensions. So like for this clamp, for example, there's an extension coming out back side. There's another extension coming out the front side. So let me go up to the next point up here. Let's go through the next. Oops, that's not what I wanted it to do. Let's grab this one here. There we go. So you see there's a backwards extension, and if I can get the right arrow, there's a forward extension on parts. All right, so I've got those 3 points defined. The last one is going to be on this terminal up here. So let me select this one. Whoops, this one. And with a spline path, you get the the tangency coming out of the ports based on how long your extension is. So there's the first path. I'm just going to go ahead and click OK, and we're done with that. And then let me run a few more, and let's try to get these remaining components connected together here. So let me do another path, and in this example, I'm going to start from an interior portion of an existing path. So you see these paths are consisting of splines. You see that's a spline there. If you want to start from a point in the middle of an existing routing, just make sure you've got your point on curve enabled up here. So I've got point on curve. So let me start off. Maybe I want to branch off from here and then go to this port right there. Let's go ahead and choose that port, and you'll see what that looks like. NX is going to go ahead and assume a particular direction based on the points and where they're spaced relative to each other. If that's not the right direction, of course, you can double click and get that to go the other way if you like. So again, it's up to you which direction you want to come off there. So I'm just going to go ahead and click OK there. All right. I've got 2 other connectors up here. So let's do a couple other spline paths. So I'm going to come off of this port and come up to this multi-port on that lower connector. I'm not real crazy about that extension. Let me pull this out a little farther. So at least we got some straight length here. Let me go ahead and click OK here. If you watch the message line down here at the bottom, it should tell me there's no violations. Yeah, whoop, it flashed really quickly. So there's no violations as long as I've got, proper extension lengths and, nice gentle curves in my path. So let me do another spline path here. I'm going to just come off of that same port. Let's make use of the quick pick there, and then go to the similar multi-port on the top connector. And yeah, that one must be set to a 0 extension. I'm going to pull this out. Pull that out a little bit farther. All right, so I've got those. And then some other commands. Let me show you some of these other commands in here. So if you wanted to actually break a segment, so this is what I've got highlighted here. This is a segment of the path. And then these segments are broken up by these routing control points. These are RCPs for short, RCP routing control point. So if you want to insert a control point in the middle of a segment, you can subdivide that segment there and then break off from that point with other branches of your path. So there's a subdivide command up here. Let me show how that works. I'm going to move my dialog a little bit here. All right, so let's go and I'm going to select this segment. It puts a point out here, and then you can just slide this point along to wherever you think you want to break that segment. I'm going to put it here. And click Apply, because I want to break this segment up here somewhere, because I've got another branch I want to make up here towards the top. So now what used to be one segment is now 3. So if you see where I pass my cursor here, you'll see 3 different segments. Okay, so let's run a few more paths. Now there is something called a heel. Let's see, where did it go? Heel path. Heel path. If you work with freeform modeling in NX and you're familiar with the bridge curve, where you define a start and an end, that's how heel works. I'm going to go ahead and create one here. When you're dealing with a general path and you got multiple points, you're probably going to want to use spline path. But if you do have a simple path you want to create that's just a start and an end, you can use the heel command. So maybe you want to start at the end of this segment towards the bottom. As you can see here, I'll just select that end. You'll see the arrow coming off. And then for the other end, maybe I want to come off of this port on this terminal. So let's just select those. You see I've got some extensions to play with. Don't worry about the straight line. If you've got your method setting correct, like for wiring, you probably want to use splines. It will give you a spline, so don't worry about that. So let me click OK, and you'll see what it looks like. So you get a nice, smooth spline there. Again, it's like a bridge curve in modeling. You just pick the start and the end. So if you've got any intermediate points that you want to work with, heel is probably not going to be a good choice. So let me do the same process. I'm going to go ahead and connect this other terminal over here using the same process, but I'll use spline instead. So I'm going to go ahead and subdivide this segment right here. Here's my point that appeared. I'm going to drag this back a little bit. So now I've got a routing control point, an RCP there, and I can use that point for my spline path. So I'm going to go ahead and select that point, and come off of this port over here. So I get that shape there. I click OK. And I think I've got one more to do. I want to go down to this rectangular connector down here. So let me do one more spline path, and I'm going to show you how you can manipulate the path a little bit as I do this one here. So let me come off this point here, and then come down here. I've got this Now, if I feel like this path is getting too close to some other components, I can go in and insert a point. Again, just make sure that you've got your point on curve command available. So let me just kind of find a good spot here. I'm going to go ahead and insert a point there. So I get a control handle here, and I can activate my manipulator just by clicking that control point, that handle, and then I can move my path around to make sure I avoid any obstacles in my assembly. So there will be another point that gets inserted there. I'm just going to go ahead and click OK. And that's what that looks like. So that point will stay there. You know, if I had a clamp or something, I could have put a clamp up there and then routed that that path through that clamp. And if the clamp moves or if a part moves, let me just show you that. The path is associative. So I'm just going to go ahead and move a part down here. You can use the move part command here in routing, or you can go ahead and use the move component command under assembly. So they'll accomplish the same thing. And actually, I'm just going to go ahead and actually use the assembly's move component command that is embedded within the move part command within routing. So I'm just going to go ahead and select that part down here, and you'll see if I use the dynamic method, and if I move this around, see how the path is going to follow. So it updates real time as I'm moving the part around. So I just wanted to show that. I'm not going to go ahead and move it. I'm just going to cancel this. Okay, so we've got all of our paths created. Like I'm pretty good on time still, so let me go ahead and work ahead here. Let's go ahead and finish the logical design of our routing. So if you take a close look at the navigator, there's a couple other palettes here. One is the component navigator, and this is where we want to identify the parts in our NX assembly that correlate to parts that are defined in our electrical design, which means these are going to be parts that are going to be connected by wires. So you can do it manually by adding entries in this navigator row by row, or you can import a component list that might come from your electrical design package, maybe your schematics package. So to save time, I'm going to go ahead and import such a list. We import one of those. And I'll show you what this looks like. So I'm going to go ahead and import. This is just a text file. And what this does is it identifies a unique ID with each part by component name that exists in the assembly. So you'll see if I sort by part name, you'll see that there's multiple occurrences of different parts. But each individual occurrence needs to be identified uniquely. So that's what the connector ID does. So we import our list, and then we want to associate each entry of that list to the parts in the model. So I'm going to do something that's called auto assign, where NX is going to go out and look at the part names in my list, and it's going to match it up to the components that have the same name. So let's see what it does here. All right, so on the left-hand side here, you'll see green check marks. These are the parts that have unique names that NX was able to find, and it identified those. The ones that's still with the red slashes there, NX did not automatically identify those because there's multiple occurrences of those parts. So we need to give NX a little bit of help there to tell which one's which. So that's where the manual assignments come into play. So I'm just right-clicking, doing manual assign. So for component P9, it's found it down here. It's found one model with that name, and if I click next part, it shows me another part with that same name. So there's two of those. I just need to decide which one is going to be P9, and I just leave it at the top. And now I've got another occurrence of that part. We're going to call that P10, and that's going to be the one that's left over. So now those two have been uniquely identified. If you look at the the component navigator, those will both have green check marks now. So we'll do the same thing for these other two terminals. I'll zoom in so you can see those a little bit better. So we've got P7. It could be either this terminal, or if I click next part, it could be the other terminal. Let me just go ahead and click that one OK. And then the remaining connector that's not been matched is P6, and it's highlighting the remaining one there. So I just click OK there. So I've got all of my parts in my component list identified. Each entry is matched up with a model that actually exists in my assembly. Okay, so let's go over here to the next navigator that's involved in routing, and that's the connection navigator. This is going to define the wires that actually connect each of the components by ID. So if I scroll over here a little bit, you'll see it's got, there'll be a connector ID that we're from, and if we're doing terminals, it's going to go from a certain pin to another connector with a specific pin on that second connector. So again, you can make these entries manually, or you can import a list from your schematics package. That's what I'm going to do here to save some time. So let's grab a connection list. And each of my wires is going to have a unique ID. And they're going to go from the connectors that I've just recently identified. So if you remember, I've got a P10 and a P1 and a P9 and all those. This connection list actually has pins defined, so terminals were defined. I'm not going to route to that level, but we're going to go ahead and route wires between the connectors. So we're going to go from, like in this case here, connector J2 to connector P8. If I right-click this and do a display, you'll see those two components that are going to be identified, and it's going to try to find a path that connects those. That's how the wiring works. So let me, I'm going to go ahead and try to auto route the entire list at once. So it's just going to select everything, and let's do an auto route just to the component level. It's kind of limited on time. So here's what happens. For all of the paths that NX can find between the components in the list, it's going to go ahead and route that wire based on whatever gauge was defined. I should have probably shown, I don't think I showed that to you, but back out here, there's a, I got to go ahead and let's go to a full display. You'll see that then. Okay, yeah, so there's a certain gauge wire associated with each of these. So it's going to go ahead and find all of those paths and route the wires in there. You'll see where it changes size when you've got multiple wires coming together into the harness. We've got two wires coming in, and harness gets a little thicker. You got more wires coming together. I think it gets even thicker once you get back to the other side over here. And you get a report, and it looks like I forgot something. So there's a routeless C4 the path was not found. So let me set this aside here. So C4 is up here. Let me do a display on this one. Oh yeah, I've got this path undefined here. This is the part that I added, and I forgot to go ahead and put that. Well, I didn't forget. I left it out there on purpose. I wanted to show you how you can update things. You don't have to go end to end in sequence. You can always go back and change things. So I want to show you how that works. I also wanted to show you how the NX finds mistakes that you might make. So it found that mistake that I made here. Let me go ahead and add a spline path. I'm going to go from this point right here, and let's go to that port. So I got a path, and that looks like it's going the wrong way. So let me reverse it. It didn't reverse on me. Let's go this one. Let's reverse that. There we go. Reverse it coming out the other way and going over there. So now I've got a path, and let me go ahead and route that. I should be able to auto route this one now. And it goes ahead and finds that, and you see down at the bottom it says, no, whoop, oh. It went away already. There were no violations found. So my harness is finished now. One way you can tell is if you look at the navigator and everything's green. You can look at the connection navigator, everything's green. Component navigator, if you expand the tree, everything's green. So everything looks good here. Let's go ahead and take it to the next level and create a form board. I think I got a few minutes left, so let me try to get through this here. So I'm going to go ahead and let's make that harness our displayed part. All right, so here's our harness. Form board is going to be pretty straightforward. If you create the form board drawing up here, you're going to be asked to specify a drawing size. And don't sweat over this. You can change it later. I'm going to pick the biggest one I have available. As soon as I click OK, NX is going to find the longest run in my harness and lay it out straight, and then provide all the other branches coming off to the side. So these are the kind of the default arrangements. If you'd rather have just standard angles here, just coming straight out at 90-degree angles, you can change your branch angles down. But this is a 3D, still a 3D harness. It's just straightened out to show what that form board would be. And let me straighten that up and click OK. So there's your form board. You can place this view on a drawing and add all your callouts and things. So I got a couple minutes left. Let me make a change. I'm going to go back to my assembly. So I think I showed you this earlier, but I'm going to go ahead and make this change permanent. Let's go ahead and move that connector and see what happens. So I'm going to go ahead and select that connector. Let's go ahead and move this up and over. Click OK. All right, and then let's go over to the, well, you can see the harness updated real time. So the wiring harness is up to date already. So let's go to the form board though. So the form board does not update automatically. So it gives you the chance to review what's going on. So let's take a look at updating our form board. And then before we just blindly update the form board, you might want to take a look at what actually changed. So there's a button here for finding discrepancies. So you can see what's changed. If I go ahead and select the discrepancies in the list, you can see that. And if you remember, this is the connector that I moved. So this branch of our harness is going to change. The length is probably going to change. As you can see, their cut lengths are changed. There's 3 wires in there in this part of the harness. And those are going to, I think there's 3. All right. So let me go ahead and click apply. And, the harness updates, the form board updates. It gives you a report of exactly what's changed, so you can print that out if you want. Just to be on the safe side, you can click Find Discrepancies again. You'll see there's no other discrepancies. So this form board has been updated. So everything's associative, from end to end in the wire harness. So if you're working with your assembly, make some changes. You can change positions of your parts, change your paths. Your form board and your drawing is going to update. So I think I made my time. Let me go back to my summary here. Go back to my PowerPoint. Just want to thank you for joining me here. And again, if you have any questions about NX electrical routing, feel free to reach out to me. My contact information here. My email is pretty simple. It's just my first name dot last name @swishtech.com. Well, thanks for joining me, and thank you very much, and have a great day.